Welcome to our Claude Code Agentic RAG masterclass. Despite all of the advancements over the last 12 months, RAG is still the fundamental way to ground your AI systems in your private company data. Because what else is there other than retrieval? We can't easily pre-train LLMs on private knowledge, nor have context windows grown to the point where we can stuff absolutely everything in and ask questions and get reliable answers back. So we still need retrieval augmented generation. There has been an evolution though, from naive RAG to agentic RAG. Vector search is no longer seen as the silver bullet for all retrieval. A hybrid strategy is needed that encompasses things like Text-to-SQL for structured data, text-to-cipher for graph data, bash commands to grep file systems, and more. And the retrieval mechanisms have changed. Where we once only had simple tool calls, we now also have MCP servers. Agent skills now allow you to package up domain expertise and knowledge. And code execution in sandboxes allows a much more flexible execution of a retrieval strategy. And as well as all of that, the agent harnesses have taken leaps forward, allowing much deeper research into your knowledge through the use of sub-agents and retrieval loops. So these retrieval engineering and context engineering skills are incredibly important to have when building out these systems. In this video, we're going to collaborate with Claude Code to build an agentic RAG app from scratch. And I invite you to follow along using the project docs in our GitHub repo that's linked below. This includes everything you need, the PRD, the prompts, the whole setup to get you up and running. And by the end, you'll have something like this, a RAG web app with a feature-rich chat interface that uses advanced agentic RAG techniques and a complete pipeline to ingest documents into your system. A lot of RAG content online is either too surface level or it's too deep on theory. So here we're going to dive straight into building and you can learn the key concepts along the way. My stack here is a vanilla Python backend, we're not using any frameworks here, a React frontend, and then we're using Supabase for vector search, database, and file storage. And we're also using DocLing for document processing. But you can swap in and out whatever tech you want and take it in whatever direction you want to go. In this build, I use both cloud AI models and local AI models. I have a server here with an RTX 5090, so we put that through its paces using the various Qwen 3 local models. So you can build this app completely air-gapped if you want, but if you don't have the hardware, don't worry about it, you can use cloud APIs. Claude Code is our tool of choice for today, and even if you've never used it before, you'll see my full development process. How I use markdown files, the plan, build, and validate loop, slash commands, git commits, and ongoing context management of the agent. And a quick note on who this course is for, you don't have to have used Claude Code before, nor do you need to know how to code. What you do need to be is technically minded and willing to learn about things like APIs and databases and system architecture. Because in the workflow that I'm going to show you, you're not the one doing the coding, Claude is. Your job is to guide it, to understand what you're asking it to build, to catch when something goes in the wrong direction so that you can course correct when needed. And this requires technical thinking and patience. And if you put the work in, you will learn a huge amount along the way and develop your core skills. And a quick intro if you're new to the channel, I'm Daniel. My brother Alan and I run the AI Automators, and we have been neck deep in RAG over the last 12 months. We produced over 30 deep dive videos on advanced RAG techniques on our channel. My previous RAG masterclass has over 60,000 views, and we have a community of hundreds of builders all building production-grade RAG systems. And Alan and I both are developers, so we have a combined 35 years of experience in the tech industry across various roles. From building solutions for small businesses, to deploying ERPs and e-commerce platforms in large-scale enterprises. I mentioned earlier that we're collaborating with Claude Code on this build. And there's a lot of talk right now about long-running autonomous coding agents, like the Ralph Wiggum loop. With these you can delegate entire projects and essentially walk away and come back and you have a finished app. And these are two fundamentally different philosophies with AI-assisted coding at the moment. You either collaborate and stay in the loop, or you delegate and walk away. And the reason we're using the collaborative approach today is that we're learning as we build, and it allows the solution to evolve on a solid foundation. The specs we've provided have enough info to lock down the tech stack and a high-level list of features across 8 modules. But we have intentionally left it light on detail, so you can figure out the rest with Claude during the planning stages of each module, and through that you'll learn how to leverage the tool as well as build the fundamental skills along the way. So in this video you'll see every decision I make, every correction and every moment I steer Claude Code, and your build won't look exactly like mine. These systems are non-deterministic, so you will get something different. Let me know in the comments where you stand on this, autonomous coding agents versus actually collaborating and staying in the loop. Along with our GitHub starter repo, we've also included our own code files from Module 1 and Module 2. So that way, if you hit a wall, you can grab our files and jump into the next module with a solid foundation. Code files for the remaining modules are available exclusively to our community members, but to be clear, you don't need them. The PRD, the prompts, should be enough to get you over the line. This video took a huge amount of work, so I'd really appreciate if you gave it a like below. It really helps us out. And if you do get started, don't forget to bookmark the video so that you can come back and pick up where you left off. This is the first video in our Agentic RAG AI coding series, so make sure to subscribe to the channel to catch the next one. Okay, let's jump into the high-level architecture. Let's start with how all of this works locally. Within our local computer or our local network, we have a code base. So we're using Claude Code. I also use an IDE during this build, an integrated development environment. That way you can see the code files and actually make changes if you want. But essentially, these are the tools that we're using. And the code base then, from a front-end perspective, uses these technologies. So first up, we're using React, which is a toolkit to build out interactive user interfaces. And for safety, we're using TypeScript, which works very well alongside React. For styling, we're using Tailwind CSS, along with the ShadCN UI library that Claude Code can use to drop in pre-built components, like buttons or forms or dialogues that look professional out of the box. And then this whole front end is then bundled using Vite. And this is essentially our build tool that takes all of these code files and packages it up into plain CSS, HTML, and JavaScript that web browsers can understand. So that's our front-end tech stack. On the back-end side, we're going to be using Python with Fast API. So this is essentially the brain of the application. And we also have DocLing as a library that we're using for document parsing. So it's a JavaScript front end and a Python back end. Now we could have used JavaScript for both the front end and the back end, but Python is essentially the primary language in AI development. All of the major SDKs, the eval libraries, the parsing tools, they're always Python first. And by its very name, Fast API is incredibly fast for communicating between the back end and the front end. So as I mentioned, this is the local architecture. So this front end, when you run npm run dev, or when you get Claude Code to run it, that essentially compiles all of that down to HTML, CSS, and JavaScript. So all of that happens on the Vite dev server, which is essentially a Node.js server. So in our build here, that's accessible on localhost 5173. That might be different in your build. But essentially then that serves to you in the web browser. And any changes that are made in the code base will instantly appear to you in the web browser through this Vite dev server and the hot reload. So the front end is rendered via this dev server. The back end is rendered via this UVcorn server. So for us, this is accessible on port 8000. And our built scripts from the front end will be communicating with the back end over HTTP or SSE to stream messages. So that's the code base. They're the two servers that are running locally. That's us in the web browser. So outside of that, we have a database. Now in this project, I actually use supabase.com. So this is sitting within cloud services here remotely. So it's not in our local computer or local network. You could run Supabase locally if you wanted. You could just spin it up on Docker. But essentially, the backend can persist data into Supabase. And the web browser also has a real-time connection to Supabase. So if any data changes in this database, it's immediately reflected in the browser. And then in terms of AI models, in this build, I use both local and cloud models. So I'm using LM Studio and various Qwen 3 models here. So the backend, the Python backend, that server can communicate with those models. I do at times also use OpenAI and OpenRouter, so it communicates out via that path as well. So that's our local architecture. This project remains local. We don't actually deploy it remotely. But if we were to do that, the production architecture, if it was in the cloud, for example, would look something like this. So we have our local code base, and as changes are made, we commit those changes and push them to our remote server. So we're using GitHub here, and that way then we have a remote version of our code base. And then depending on whatever infrastructure you have set up, you can trigger builds or trigger deployments when new pushes are made to that remote repo. So for example, on the front-end side, if you were using Vercel or Cloudflare, or if you had your own server and you were using Nginx, you could configure it in such a way that when changes are made to the repo, it can trigger the build of the front-end app. So again, you're getting that full tech stack, all of the code files, and you're building it or compiling it to HTML, CSS, and JavaScript. And then that's accessible via the web browser. So if someone accesses rag.app, for example, it would be served by this front-end server and they would just get those files. And that's the same on the backend then. So you can deploy from GitHub. Essentially, you're going to be pushing it to the backend server, and it uses UVcorn and Fast API to be able to send data to the front end. So in this case, if you think about it from a domains perspective, this one would be rag.app, and here you might have api.rag.app. So that's the data feeding the front end. And again, you have a database, so you would be using authentication within this web browser, and data will be streamed through from the database. So we'll be getting into the likes of row-level security and kind of authentication in module 1 of the build. And that in a nutshell is the production architecture. Now you could publish this locally to the network. So if you wanted to run this air-gapped behind a firewall, you could just trigger the build yourself to a local server and make that accessible via the network. So onto the project. What are we actually building here? Well, we've broken this down into 8 modules, and we have this PRD document that's in the repo that you can download. So we're building an Agentic RAG application that has 2 primary interfaces. There's the chat interface and an ingestion interface. And that's essentially what you see here. So this is an example of the chat interface. And while it looks simple, there's actually quite a lot going on here. Not just threads of conversations, but you have all of the various tool calls, sub-agents triggering, streaming and markdown rendering, chat history and memory. There's a lot going on in these interfaces. And then on the second side, we have the document ingestion where you can drop in files. And then there's various statuses of files as they're processed, metadata extraction. But of course, this is just the tip of the iceberg. You can bring this project on much further after these 8 modules. So step 1 is to create the app shell. So it's linking it with Supabase. So we're using Supabase for authentication. So users can log in, and through the use of something called row-level security, their data is isolated from other users within the system. And by the end of module 1, you will have a chat interface. I call it managed RAG because in module 1, we're going to use the OpenAI responses API. Now, if you don't want to use this, that's fine. You can use something else. But there are plenty of people that might just want to build a wrapper on OpenAI's responses API, or perhaps Gemini's file search, for example. So that's essentially what this module 1 is, creating the chat interface, creating the login, and getting a basic chat up and running with a cloud model. And then from step 2 onwards, we no longer use the OpenAI responses API. We use the more generic chat completions API, and then we can use any number of models, both local and cloud. So then for cloud, you can use OpenRouter, and for local, I'm using LM Studio. So module 1 is the chat interface. Module 2 is our data ingestion interface, as well as the backend flows for that. Here we're using PG Vector within Supabase to actually save our embeddings for our documents. In module 3, we build out our record manager because we want to avoid duplicating files in our knowledge base. In module 4, it's all about metadata extraction and filtering. So this allows you to narrow your search across documents in a vector store, which can lead to much better results. In module 5, we hook up DocLing for multi-file format support. DocLing has a standard pipeline, which is what we use. You can also use VLMs with DocLing. And again, those could be local VLMs or cloud VLMs, depending on what hardware you have. For module 6, we implement hybrid search and re-ranking. So we're no longer relying just on semantic search. We also bring in keyword search, and we can use a local or a cloud re-ranking model at this point. Module 7 is building out additional tools for the agent. So this is where it becomes really agentic RAG. We create a web search tool, and we also create a text-to-SQL tool. So the agent can write and execute arbitrary SQL commands against a table in a database. So a key aspect of this area is database level security. So we only want to provide read-only access to a specific table for the agent. We don't want to let it loose on the entire database with the potential to delete everything. And finally, in module 8, we build out sub-agents. So similar to the way Claude Code does this with their own Explore agent, we ourselves create an analyze document sub-agent. And this allows a completely different LLM to load up an entire document into its context window to carry out some sort of extraction, summarize or extract out insights or look for a particular topic. So the beauty here is that it's not cluttering the context window of the main agent. That can stay focused on answering the user's question in the interface. The front end becomes quite complicated at this point because we are rendering all of the tool calls, the sub-agent's thinking process. So this is where things really get interesting. And I forgot to mention that across all of these modules, we're using LangSmith for observability because we need to be able to see what's happening behind the scenes with these LLM calls. What prompts are being passed, what tools are being called, what memory is in context, because context management is crucial for these systems to work. So you will end up living in LangSmith, looking at traces, trying to figure out what actually is going on. And before we get started, I just want to call out the AI dev loop that we use here. So we have our PRD, we have the 8 modules. At a high level, we know what features we're going to be implementing. So for each of those phases then, each of those features, we're going to go and use Claude Code's plan mode. And as I mentioned, we've kept the PRD light. So we're not using SpecKit or BMAD or any of those upfront planning tools for this project, because the idea is I want to show you how you collaborate with Claude Code to get to an end result. But they are by and large great solutions. But for this, for each major phase in the PRD, we use Claude Code's plan mode. And then you can have a back and forth with Claude Code on that phase, on the features, on the acceptance criteria. And then we work through to the build phase where Claude Code will go and build that across the main agent, maybe numerous sub-agents if it's a phased build. And then it will produce an output, which then it will carry out some level of validation, but then you also need to carry out your own manual testing and validation. And that typically results in a back and forth. You might need to clear down the session at that point and start fresh, because you need to manage the context window. But eventually you'll get to the point where you commit all of those changes and you move on to the next phase, the next section of the PRD. So this in general is the AI dev loop. What I have found is if you build out a feature and if there's lots of problems, if there's lots of changes, sometimes you might need to create a separate plan just to solve a particular bug or to add a specific feature. But generally, this is the main loop that you will be using constantly. And on the version control front, we have kept things simple for this course. We're just going to use the main Git branch. Now, it is better practice to have feature branches and then merge code into the main branch. But for those who are starting off in development, I don't want to overcomplicate things. In the next few videos, we're going to dive deeper into actually how you have more formal version control, branching of the code bases, merging in deployment across dev, staging, and production. There's a few pieces of software you'll need to get started. Obviously, the first one is Claude Code, but we also want to use an IDE because we want to have visibility on the files as they're being created. So you have options here. I generally tend to use Cursor, but you could use Google Antigravity or VS Code. I won't go through the process of installing Claude Code or these IDEs. That's covered in numerous videos online and the instructions are pretty clear. But once you have them installed, the next thing you need will be the source files to kick off the project. This is published on our GitHub account. It's linked below as well. And it contains all of the setup markdown files that Claude Code needs to actually work through this project. So just grab the URL at the top. And there's lots of ways to clone this repo. You can do it in Claude Code. You can do it in Terminal. I generally do it in the IDE itself. So I'm going to use Cursor. So that's opened up here and I have a clone repo option. So we'll just hit that and then I'll paste in my repo. And I've just created a folder, so I can now select this as my destination. And then that clones the repo and brings down the files. So let's open it up. And within Cursor, you get this view. Press Ctrl B or this button to open up the sidebar. And now we have a view of the files in the repository. And this is important because we want you to be in the driver's seat as you actually build this out. So even though you don't necessarily need to know how to code, you should have a general sense of how the code base is progressing and evolving. Great, so with our repo cloned, we can then open up the terminal. So there's a few options here. You can click on New Terminal at the top. And then within this folder, we are in the Claude Code Agentic RAG masterclass. I can just type in Claude because it's installed, and that should open it up. Now you can use this within the terminal here. There's also a Claude Code extension in these VS Code forks that you can see there and install. I have found that using Claude Code in the terminal like this can actually be a little bit laggy and a bit glitchy. Let's start with it here, and if it becomes unbearable, we might switch to a separate terminal alongside the IDE. And before we get started, I do recommend that you configure a status line as you see here. So here I can see what model that I'm using, the percentage of the context that's actually been consumed. So for example, if I just type in hi, you'll see now that I'm using 10% of the context, which is 20,000 tokens. And context management is absolutely critical when you're using Claude Code or any AI coding tool. So you need to keep an eye on these numbers. Generally speaking, if that goes over 50%, I generally look to start a new conversation. So if you want to set this up, I'll leave a link to CC status line, which is the GitHub repo, in the description as well. And there's lots of configuration options you can use with this, but it's really worthwhile setting this up. So let's work through some of the files in our repo. The first one is our global rules, our claude.md file. And we've kept this pretty lean because obviously this will be loaded on every single thread, every single conversation we have with Claude Code. Essentially, we're just describing the tech stack, some of the rules of engagement. So we don't want to use frameworks. It's kind of raw code, raw SDK calls, and explain things like how we want row level security so that specific users can only see their own data. So we'll be using the Claude Code planning function quite a lot. And I've described here how I want these plans saved to our agent plans folder, a naming convention on the plans, and then also talking about the complexity of the plans and whether it's feasible for them to be done in a single shot or not. And then I just described our development flow about how we plan, build, validate, and iterate. And finally, we want all of the progress to be tracked in our progress.md file, which is best practice. That way, new agents, as they're spun up, will be able to figure out very quickly where the project is at and where they need to continue. So just to jump into that progress.md file, it's pretty lean and the agents can build this out as they go. And our convention is not started, in progress, or completed. We have our PRD then, which is our product requirements document. And this is essentially the modules, the phases of the build. So we've described what's in scope and out of scope, and then we've broken down each of the modules. So initially we're building the app shell, then we're going to have our own bring your own retrieval and memory, building out record managers in module 3, hybrid search in module 6, and then add in additional tools and sub-agents. So this is our global product document that will be basing everything off. So outside of those then, within our Claude folder, we have a couple of commands. We have a build command, and this is the iterative cycle of planning, building, and then testing. So essentially we're telling it to read the entire plan, execute the tasks in order, and then test and validate. And one thing missing here is just for the agent to update our progress.md file with how the task has progressed. And finally, the last one is our onboarding command. And I'll show you this in a couple of minutes, but essentially when we start from scratch, we want a way to be able to onboard a new agent who has no context of the project with what the project is all about and with where we are in the progress of the project. So let's actually trigger this onboard / command. And then based off this prompt, it's actually scanning the project structure. It's looking at the Git log, even though there isn't any at the moment. And it's grounding itself in the project so it knows where to start from. Cool, so it can figure out that the current state, nothing is done, module 1 has not yet started. So we're ready to get going. So we're going to kick off module 1 where we build out the app shell. We set up observability with LangSmith and we hook up Supabase. So we're going to get our login screen up and running using Supabase auth for user management. And by the end of this, we're going to have a chat interface. We're going to have managed RAG up and running using OpenAI. Within the OpenAI playground, we'll be able to create a vector store and drop in files into that vector store. And through our chat UI, we can have a conversation with those files. Now, if you don't want to use OpenAI, and if you want to use something generic, you could just get it to use the chat completions API for whatever model you want. You could use OpenRouter, use a local model. But I wanted to include this in this phase because there's lots of people that might want to just build a wrapper on OpenAI's responses API or the Gemini APIs and use their managed RAG. So feel free to update your plan depending on what you want to do. So currently we're in the editing mode, as you can see here. So I'll just press Shift and Tab to enter plan mode. And I'll use my voice to text here. Let's kick off the planning for module 1. Okay, so let's let that run. And we can see it's going to launch a plan sub-agent to actually kick this off. And this is great because it protects the context window of the main agent, which we can track here. So we're at 12% at the moment. Whereas you can see this planning sub-agent is consuming its own tokens. So it's given us options here on would we like to proceed with the plan. Generally speaking, no, not yet. Because we're in plan mode, it's read-only mode. So I want to save this plan into our plans folder on the top left, because I want to keep a history of all of these plans. And that way, when we need to onboard a new agent, he'll be able to jump in and see what plan we were working on. So we'll just exit out of that. Just press escape. We'll get out of plan mode. So just shift tab into edit mode. I'm just going to ask, can you move this plan into our agent plans folder? Okay, so it has added that now, and it's based off the naming convention that we have in our Claude MD file. And this is why I didn't want to just accept what it provided. I want to actually read this plan and make changes if needed. So it's talking about how the complexity of this is medium, because there's actually quite a bit in this, building out the foundation. It gives an idea of the structure of the front end and the back end. Task sequencing, so set up the back end first, then the Supabase client, then the database. So yeah, there is quite a lot in this. We could break this up into multiple tasks. Let's try to execute this in a single shot. And if it can't make it, we'll be able to pick up a new agent and we'll get it to update the progress file. So at this point now, I could just get it to build out this plan. Generally speaking, I prefer to clear the session and start from scratch. We have consumed about 50,000 tokens here. So if we start this really long running feature build, we're already using about 25% of our allocation. So we're probably better off just to clear it completely, which is just /clear. That'll bring us back to 0. And now I'm going to use my / command build, which is the one up here. So /build. And now I'm just going to drag in this plan, which you can see here. Now you could also just copy a relative path and paste it in there if you're on the terminal. But we'll just build from here. We're starting with a completely fresh context, but it has everything it needs in this plan to actually be able to succeed. Okay, and it's off. And it's created the tasks within this module, within this phase. So 14 tasks to work through. And this is what's nice about using an IDE is you can see the files being built out as Claude progresses. So we can see that it's working on the back end. And it's back to this idea of you being in the driver's seat. You don't necessarily need to understand everything that's in this main.py file, for example. But it is important for you to have a mental model of how the code all fits together. So we can see that we have the backend folder. Within that, we have the app. And then there's database, models, routers, and services. And another reason to use an IDE is that if you have a subscription to the likes of Cursor, you can use their agent mode, which you can see here on the top right, and you could ask it to explain some of these files. So once the backend is complete, you could drag that in here, and this is Opus 4.5 as well, and you could ask, can you explain what this folder is, how the files work, just to give you a better understanding of how it all fits together. And this is really important because you need to track the progress and the evolution of the app. The other thing is you could run this in YOLO mode, which accepts all commands. I generally prefer just to keep track of the commands that are coming in. We have a settings.json file that has a number of permissions that are allowed. Certain ones are denied, and then others require to be asked. So here, npm create commands, we will allow. And again, you can ask Claude either in the agent browser here or within Claude Code what these commands actually mean if you don't know. So we're progressing through our tasks here. We're at task 4, and we've only used about 17% of the context window. And that's why it was a good idea to clear it down, because that was already nearly at 25% without any of it being done. And I mentioned that Claude Code can become a little bit buggy within the terminal of the IDE. And you can kind of see that here, where it's not really rendering out correctly. But it hasn't become a blocker as of yet. Okay, so that took just under 13 minutes to build out all of the tasks. It's now updating the progress report. So it's added all of those tasks to module 1. Now it has outputted the next steps for the user, and I am conscious it hasn't gone through the validation steps in the plan. And it has been a little bit lazy here by telling me to go run scripts and run commands. But there is one area that I do need to add, which is this one around environmental variables. So we need to copy the env example to .env. So let's just do that one. So this is sitting under backend. So we'll just copy and paste that. And let's rename it with F2. So it should be just .env. And then we need to add our Supabase credentials. So for this project, I'll use supabase.com. You could run this locally if you wanted. You could bring down the Docker containers that contain Supabase and then ping it that way. That might be something we might do in a future video, but for the moment, I'll just use supabase.com. You can create a free account on Supabase with up to 2 projects. Now, it does turn them off after a few days, but just to get up and running, it's well worth it. So I have created a project here, my Claude Code RAG masterclass. And if you look at what we need, so the Supabase URL is the first one. And that's down here under project URL. Now these environmental variables might be different for you because obviously it's a probabilistic system. It'll produce something different for everyone. So we need the Supabase anon key and the service role key. Supabase has these new publishable keys. It's not that, just in case you don't know. Click on API settings, API keys, and just use the legacy keys. So we'll copy that in. And then this is the service role secret. So then we also need an OpenAI API key. So let's go and get that. So for module 1, we're going to use OpenAI, but for module 2 onwards, you could use something local like Ollama or LM Studio, or you could use any LLM on the likes of the OpenRouter platform. So all of those services support the OpenAI SDK format. Okay, so that's the key. I'll delete it after this video. LangSmith API key, this is important because you need some way of actually seeing what the LLM calls are going back and forth from your custom app to OpenAI in this case. So LangSmith is a good platform for this. Again, it's a free account you can set up. Okay, so we're now in, and just on the bottom left, go to settings, API keys, and then the top right, you can create one. Okay, that is the API key. And then the project ID, we'll just give it as RAG Masterclass. Okay, so we have our env set. So now I'm going to go back to Claude. Can you carry out the validation steps that were in the plan? And also these next steps for the user, can you do these? I have created the .env file in the backend folder and I've applied API keys. You just can't see it because you don't have permission to see it, but they are there. Cool, so it should be able to use the actual variables. It shouldn't have to be able to see them. So have you also created the env in the front end folder? No, I didn't. And then have you run the SQL migrations in the Supabase SQL editor? I'm going to say, no, I haven't. Can you run these? So it's asking which Supabase project we should use. So I'll just copy the ID of the project. So again, the back and forth you're going to have will be different to the back and forth I'm having. And it looks like I'm on a different Supabase account within the CLI. We are now logged into the right account. Please continue. Great, it looks like we're linked. And it's now going to start carrying out all of the testing that was in the original plan. And the other thing we probably should have done when we were actually doing the original feature build was we probably should have got sub-agents to do things in parallel, because the back end probably could have been spun up at the same time as the front end. So that would have saved some time. It took about 12 minutes in total, so I might have cut that down a bit. So we're nearly finished this validation. We're approaching 50% of our context window, nearly 100,000 tokens. I definitely want to be clearing this down soon. Okay, so I was running into issues there and I was hitting nearly 95,000 tokens. So I just exited my session, went back in and hit resume. And I've asked Claude just to update the progress log with where it's currently at in this validation process. So it's halfway through, as you can see, and it's blocked here. Now, at least there's a handoff to the next agent, so it knows where to take up the project. So back into Claude, and I'm just going to type in clear. That'll bring our token usage back down to 0. So fresh context. And then I'm going to ask, can you check the progress.md? We're currently halfway through the validation on our first module, and I need you to continue. And this is all based off the plan that's in the agents folder, plan number 1. So a lot of the time you'll find you're better off starting from scratch with the fresh agent, fresh context, but you just need a way to pick up where you left off, and that's where the progress log makes a lot of sense. Okay, it looks like it's now able to install the front end, and it had to actually trigger it via PowerShell. So there was a bit of back and forth there. I think what we should do is set up a kind of a startup script or a restart script so that we don't have this conversation every single time. Now it's asking me to test the auth flow. I want it to do the testing though. Can you carry out the testing of the auth flow? Can we install the Playwright MCP? Okay, I just need to restart Claude Code. Can we create a start services script that actually has the bash commands that actually work? And let's save that in the repo, and then let's update our claude.md file to describe to future agents how to actually spin up services. So generally speaking, you need to be on the lookout for prompts that you're continually providing. Any kind of duplication of effort, you need to see, is there a way that you can create slash commands, create scripts, make life easier for yourself so you constantly don't repeat yourself to the agent. So here I'm getting it to create a start services script instead of having this constant back and forth around starting the services. So it looks like both services are running, and it's just getting Playwright up and running now. Can you update the progress log with where we currently are at? and then I'll start a fresh session and pick it up from there. Okay, so let's clear the session. Can you pick up where we left off? Have a look at the progress.md file. So let's now see how the browser testing goes and the validation of module 1. Okay, so it is able to hit the login screen. So I'm getting a lot of permissions prompts, so we probably just need to add Playwright to our settings. Into Supabase, let's go into authentication, and then we'll add a user. So create new user, test@test.com, and we'll just get it to suggest a password. Here's the test username and password. Now, I don't mind actually giving Claude this because it is a test username and password. I don't need to put it into an env file. Can you save these credentials to our claude.md file so that future agents can use them for testing? And then also, can you continue the validation with this account? Okay, we are logged into our app. Brilliant. So the auth flow works. User signed in. We have threads on the left and we have our main chat in the middle. So let's see, does it do any more validation of this? Because there was a few more tasks within that module that it should validate. And it's realizing that the migration hasn't taken place of the script. So it's doing that now. So if we go to database editor, nothing appears there just yet. Okay, migration applied successfully. So let's have a look at Supabase. Cool, we have our threads table and we have our messages table. So now we come back here. Let's see, kind of test out the chat interface. We're okay context window wise here. We're at 26%. Cool, and we have an answer. So that is the OpenAI assistant responding. So that's the thread creation and chat messaging. Let's go into tracing. So nothing showing in LangSmith just yet. Okay, so module 1 validation complete. We are finished the first module. So then it's down to manual testing. And let's just check what's in Supabase as well. So these messages, yeah, between the user and the assistant. So we are tracking the kind of short-term memory for the various threads. If I refresh and click on the chat, yeah, it loads. If I open up a new chat and ask a message, it is streaming through. So this is where we get into bug fix as well. And depending on how many bugs there are, again, it might make sense to clear a session and start from a fresh bugs list. If it's only a few bugs, then you could just dump it into the current session. So I'll just try these two for the time being. The LangSmith traces aren't showing. And also, after I type in one message, I can't type in any further messages. Okay, so it claims to have fixed it. Let's have a look. Back into LangSmith. And not seeing the traces. Anything in the home? Nope. Anything in monitoring? Nope. So it's interesting that trying to get the LangSmith tracing up and running has pointed out that actually we're using a much older version of the OpenAI API. It's using the assistance one, which is sunsetting this year. Responses API is the actual current one. So I'm getting it to upgrade that library. And actually the OpenAI Assistance API was in the original PRD. So I can't exactly blame Claude Code for that. I should have read that a bit better. And that's why it is important to really read the product requirements documents before you let your agent loose. So now that we're tied into the OpenAI Responses API, we essentially have managed RAG. So if we come into the playground and go to storage, we can create a vector store. So let's call this our CC RAG. So we have a vector store ID, and then we can upload files to the vector store. So if we just click add files at the bottom and drag in this PDF and click attach. So now this vector store has a file. We can see the file there. So now if we copy out this ID, and then I'll just come back into Claude Code and I'll say, can you link the OpenAI Responses API to this vector store ID? Okay, and that's just changed the OpenAI service in the backend. So I'll just add that ID to my env file, which is what it wants me to do. So I'll save that. So I'm just going to restart the backend now. I could get Claude Code to do it, but it's something that I need to do so often, I may as well just trigger these commands myself. So I can open up another terminal here, and then let's just check to see what command we need. So I think it's in scripts, say restart all, and this is what I need. So you could just ask Claude what's the exact command. So that's restarting all services. And you can see they just popped up there as well. And now let's test it out. So a new chat, and let's ask, tell me about the Whirlpool refrigerator. Now that's actually not based off what's in the vector store. That's just general information on whirlpools. Is it possible that we have multiple Python services running or multiple front-end services running. So when we restart them, the other ones remain open. So this is an issue I ran into. I have 2 Claudes open here, and I was just having different conversations with them. And there are basically multiple background tasks, multiple servers running. So when I restart the server, it's actually keeping the other ones up. So we just need to update this restart services script that it kills all processes and does a full fresh restart. So this is the depth that you need to get to if you really want to understand how these types of architectures and these types of apps work. Between a front-end React application on Node and a back-end Python application in its own virtual environment. Okay, hopefully that has done the trick. So let's keep an eye on our LangSmith because we definitely need to see traces. Every request we make to an LLM has to show up here. We're getting a bit high on the context limit here as well. We're at 55%, so I definitely should look to clear it soon. Okay, let's try it again. And no, that's not working. Okay, let's clear down this session. The context window is getting full up and I'm getting kind of poorer results back. Okay, new session. I might just onboard this agent to the project again, just to try to solve this bug. So a key productivity hack is to have multiple Claudes running at the same time. So as one Claude agent is working through a problem, another Claude agent can work at a completely different feature, let's say, or a different bug fix. And that way you're making better use of your time. For example, this bug fix has been running for more than 8 minutes now, and it may just have solved it. And while it is interesting to track the progress of the fix, it gives you a better understanding of how the code base actually works. It can make more sense to run at multiple features, multiple bug fixes at the same time. So hopefully now we have our traces up and running and this is connected to the vector store. Let's just trigger a chat message now that that's fixed. So we'll refresh here, go to new chat, and we'll ask it to tell us about that refrigerator that's in the vector store. And we are getting another error. So this is where you need Claude to be able to validate itself. And while that Claude fixes that one, let's get another Claude up and running and we'll get it working on a different task in parallel. So we'll just onboard it. Can you carry out some front-end changes for me? So the threads on the left-hand side, currently it just says new chat. I would like these to be dynamically generated depending on the message that was passed initially. Secondly, there's no way to stop a stream of messages coming back from the agent. And another thing is it would be nice to have a loading icon when the backend is actually working, generating a response. My traces still aren't working, so I might just take a screenshot of this. I'll get another Claude up and running. So this will be my third Claude. And this time, because it's really struggling to actually figure this out, I might go into plan mode. And then I'm going to say, we're having a serious problem getting our LangSmith traces working. The env is set, and it's set correctly. That's for both the API key and the project. However, the OpenAI responses API, whatever way we're wrapping it or whatever is happening, we're not getting the feeds through. I cannot see the traces and I need the traces. Okay, let's run through our terminals. So here it's asking, do we want to proceed there? Let's do that. This is currently working through the front-end changes. And this is now trying to get to the bottom of that issue. Also, something to consider here is that the original spec was for the OpenAI assistance. However, we moved it to the OpenAI responses API, and maybe there's a legacy hangover that could be a problem. Also, check versions of everything relevant as well. Maybe we're running older versions of things. Okay, so that front-end change looks good. It was thinking. And we have the stop button now, which appears down there. That does seem to have worked. Yep, it stops it in its tracks. And yeah, we now have the dynamic titles as well. So the front-end fixes are really fast, which is quite nice. Okay, so let's ask our question again. Tell me about the Whirlpool refrigerator. Excellent. So it is now working. Whirlpool refrigerator is a side-by-side model, electrical requirements, etc., etc. So that's exactly what is in that PDF. So we now know that our vector store, essentially, this file, is accessible via the responses API in the front end. And we're able to ask questions of it. And this is managed RAG. So, you could drop in more and more files into this vector store using this interface, or you could build your own interface, which is what we're going to be doing in the next module. And you could drop files into that interface for it to push them up into the storage bucket. So all of that is possible. But what we're going to do next is we're going to get out of the world of managed RAG, because everything is in this black box. We don't have any view of the chunking. We don't have any view of the embedding models, the strategies used to actually trigger the different retrieval tools. So it is very much a black box, and you're also paying for that. So in the next phases, we're going to move away from OpenAI. We'll plug in OpenRouter, and I might even try out my own AI server here to run a local model. And let's actually put the building blocks of this RAG system together using PG vector within our Supabase instance. And the one thing we have not resolved is our tracing. So LangSmith still is not showing traces. So I've brought out the big guns, I've gone to the plan mode, and that has triggered 3 explore agents to explore the code base to figure out what actually is going wrong. And while that does some digging, I might make some more front-end changes just to keep things ticking over. So I've just burned through my Claude allocation, so I need to wait for 45 minutes for it to unblock. In the meantime, I picked up with Cursor, and this LangSmith tracing issue has been going on for ages. I used their debug mode. You can see it down here. So there's different agent modes. And this came up with a number of hypotheses from investigating the code base, and it cracked it. I have an example now where I have a stream coming through while also having the response registered. So just interesting that Claude Code, when it runs into too much of an issue, you could try Cursor or Google Anti-Gravity, and some of these different modes, they can behave differently. So if we look here, we get a streamed response. And then if we load latest, we also have our trace. And this is so important because we do need to be able to see all the various tool calls that we're going to be generating. So essentially module 1 is now complete. And one thing that I didn't do, which I probably should have, is I haven't committed anything yet to our Git repository. The idea I had was that I would commit as each module is complete, and that's why there's so much green here that needs to be committed. In reality, there was a lot of code in that module. I probably should have done a lot more incremental commits. That way I could track the actual changes and possibly revert in a couple of instances when I went down the wrong path. But anyhow, because Claude Code is currently waiting to be unblocked, I've hit the limit for this time slot. Let's just get Cursor and say, Cursor, can you initialize a Git repository here and commit this code base as our first phase? Now, the other thing is you can do this yourself using the GitHub desktop application. So here, for example, you can add an existing repository because this has now been initialized here. And if I come into this, I can see that there's 74 changed files that need to be committed. So that's essentially what I'm getting Cursor to do here. And of course, very important that we're not committing env files. So they are within the backend and front end, and you can see with this little symbol that they are git ignored. So that is done. The changes have been committed and pushed. So I've committed everything and I've pushed it to GitHub. And this is my new personal repository, which is CC RAG tutorial. It's a private repository, which is important. Now this is different obviously to the one that I'll be linking in the description below. This is my version of my build, but the one that you'll be using will be the Claude Code Agentic RAG masterclass. But it is important that you version control your build. That way you'll be able to actually roll back if you ever need to. And pushing to GitHub means that you have a remote copy as well. Just make sure that it's private. That's the most important thing. So just to demonstrate this managed RAG system, I obviously have this OpenAI storage bucket here. I've just uploaded a single file. So let's just delete that. The test files I have, so I have an SFTP folder of 9,000 PDF product manuals. So we're going to be playing with this over the course of this project. I've downloaded a few of them though. I've got like 150 files here in a local folder. And these are all appliance manuals. So if I just jump into one, this is a food freezer, this is a dryer, a built-in wall oven. So generally for RAG systems, you need to upload your documents. With this managed RAG style system, we'll just drag a few of these into this storage bucket here. So I'll click add files and I'll just drag these in and I'll let those upload and attach. Okay, so they've loaded up. And then let's open up one of them. So this is a refrigerator. Here's the product code. So let's now ask our question. How do I install the filter cartridge on my refrigerator? And I'm going to say, here's the model number. And this is where these managed RAG solutions can struggle. It's a black box, so we have no idea actually how it does it. So we're getting a rather slow stream back from OpenAI's responses AI. So there's our answer. And from eyeballing the response compared to the instructions, it does look pretty accurate. Do not push it into the holder. Don't over tighten it, which is mentioned there. So yeah, it looks pretty decent. We do have 6 steps instead of 5, which is listed here. But again, it is synthesizing based off the chunks, let's say, in this document. So you can get good responses from the likes of these managed RAG services. The likes of Gemini File Search is another good example. These are decent systems. The problem though is you just don't know what's actually happening under the hood. We've only uploaded a small number of files there, but let's say you have hundreds of refrigerator manuals. When this file search takes place, how do you know what's actually pulling the right information from the right manual? That's the thing, you just don't know. It's a black box. So that's why in the next phase, we're not going to use these managed RAG services. We're going to build out a full end-to-end RAG pipeline ourselves that we have total control over. Another downside to these managed RAG services is you're tied into a single provider. It's a cloud provider, so you don't have control over how they're actually managing the data. And you're also tied into those models. So you saw there we were getting pretty slow streams back from that responses API. So you can't swap that out for another provider. And then also there's a file search cost. OpenAI charges 10 cents per gigabyte and $2.50 for each 1,000 tool calls. So that bill adds up. Gemini File Search is a bit cheaper, but who's to say they might not increase that cost in the future? I've done a full video on Gemini File Search where I dive into the pros and cons of these managed RAG services. So I'll leave a link for that in the card above. Now that we've committed everything to Git, can you create a release for this phase? Let's tag it 0.1. Okay, so there's our release version 0.1, phase 1 application shell. And this has all of the source code and the migration scripts to get up and running. So let's create releases for each module from here on out. So for phase 2 then, I've onboarded this agent over here. I've entered plan mode. So let's jump in. We're ready to plan module 2. Can you kick this off with planning agents? So it has kicked off by exploring the current OpenAI integration. And subagents are brilliant in Claude Code. Like this one has consumed 30,000 tokens, this one 25,000, this one 15,000, but it's not blocking the main agent. We're still at the 15% mark here. And let's just dive into phase 2 and have a look at what actually is happening here. So within our PRD, module 2, we're going to bring our own retrieval. So we're going to create an ingestion UI where we can drop in files, similar to what we just did in the OpenAI playground. And further down the track, we'll create the pipelines to pull in files from folders or SFTP. So we'll be creating our own retrieval and memory. And we then need the ability to chunk and create embeddings to upsert to our Supabase kind of PG vector store. And here we're talking about having some sort of selector for a model provider. So actually it will be in the UI. And then having a real-time ingestion status for this interface where we drop in files. Okay, so we have some questions to answer. For embeddings generation, should the embedding provider be configured separately from the chat LLM? Definitely. For the plan scope, how should we break up the module 2 implementation? There's 5 distinct pieces. Let's do a single plan, but let's try to get multiple general purpose subagents to actually run at it. And we'll submit those answers. Okay, so the plan is finished. Again, it's trying to get me to do it straight away, but let's escape. And we'll just get out of plan mode so it can write files. Can you save this plan to the .agents plan folder? Now, of course, we could actually just do this ourselves because this plan is accessible. So we just control and click. That is the plan. We could just copy and paste. Okay, so there's our plan. Now, before we continue with this, can you analyze this plan and figure out if any elements of the plan can be executed in parallel? And if so, make the appropriate changes. Yeah, so it looks like we can definitely run 2 builds at the same time. Phase 3 is dependent on phase 1 and 2. So yeah, it's breaking it into stages. So this is a good way of just speeding things up. So I'll have a chat back and forth with Claude just to make some more changes to this plan, and then we'll kick it off. So let's clear down this session now. So just type in clear, and then we will use our build / command, which is build from a plan, and we'll just drop in this plan and hit enter. The plan itself talks about how it wants to run things in parallel with subagents. So hopefully that should work here. Let me have a look. Now it doesn't actually look like it's using subagents, so I might just stop it there. Can you use general purpose subagents to actually parallelize this? There we go. Now it's running 2 task agents or general purpose agents. Okay, so that is the build finished for this module. It has verified it, so I've been tracking Playwright as it actually tests out the interface. So that's quite nice. So let's do a bit of a check ourselves so that we can actually test and verify. Okay, so just hit refresh. So we now have a documents tab. So this is our ingestion flow, so we can drop in documents here. The tabs are a little bit broken there, so we can get that fixed. Let's just regression test the chat just to make sure it still works. Test 1, 2. So we are getting something back. Let's just make sure LangSmith is still working. A few seconds ago, that looks good. Then let's go into the documents and let's upload a couple of documents and see what happens. So let's grab a document from here. Let's just try one. So throw that up there. Unsupported file type. So only allowed text or markdown files. Okay, fair enough. Let's just upload a text file to test. So there we have test 1, 2, 3. So drop that in there. Okay, yeah, processing and completed. Only 8 bytes, one chunk. So let's come into Supabase. And now, yeah, our documents and chunks has loaded up. So do we have embeddings? We do have embeddings. So let's check to see what embedding model we're using. We have a bit of metadata coming through, such as file name and chunk index. That's good. We can build that out as we go. And then we have the content of the document. We have the user ID, so that's good for row level security. And we have document IDs. Okay, not bad. So storage path. So it looks like these are being stored in the buckets. So let's open that up and see. So storage, files, we have documents. This looks like a user ID, I would say. Let's go into authentication. Yeah, E3CD. So, okay, each user has their own folder. That's nice. And these are the documents. Nice. And then if I delete a document, test 1, 2, 3. So it hasn't deleted there. If I refresh, it is deleted. So maybe that's the real-time connection to Supabase is missing there. The file has been removed from the bucket. That's good. And it's no longer in the documents table. And the chunk is gone. Excellent. Let's check out the rest of the acceptance criteria for this module. Ingestion UI, file storage. So chunking, embedding, PG vector. Providing a selector for a model provider. So I don't see that. So we kind of need a config screen really for that. Chat history storage. Can we see that in threads? So we have some legacy columns here we can remove. OpenAI message ID and thread ID. So I might just sort this by created, descending. Yeah, test 1, 2, 3, 4. That's there. So if I just delete out some of these and refresh. Okay, everything's gone on the threads and the messages. So this is looking pretty good. And then if I log out and log in, so we just need to also test the isolation and the separation of data. So let's come in here and let's create a new user. This is test2 at test.com. So we're getting to the point where we need a regression test suite. So that might be something I'll talk to Claude Code about. We need to track test cases. This is going to get pretty annoying to have to keep doing these tests for every phase of the project. And with AI coding, as well as actual devs, there's always the potential of breaking something when you make a change. Okay, so I'll add these test credentials. So it's the same password. This one is test2. So this is my Claude MD file for testing the isolation of data between users. Okay, so log out. This is test2. So let's upload that document. That's completed. And now if I log out of there and log into test1, cool, yeah, that test 1, 2, 3 document is not there. This is a different document. And you can see the 2 documents in the folder and different user IDs. Perfect, this is all great. And it is important that you understand the table structure, how the data is actually separated across the tables, the buckets, the authentication, the policies. It's just good to know this stuff. So I'll just get Claude to fix up a few things, like fix up the problem with the tabs there. I'll ask it to put in that model selector, and then let's move on to phase 3. And actually, sometimes I find if I'm trying to make a list of bugs to fix, if it's a very long list, a lot of the time you're better off just to use a transcription service and just dump it into a notepad file and then just paste it all in as a single prompt. And if it's a really long list, that could be quite complicated. You might even need to make a plan to tackle the full list. If it's just a handful, it can do it in a single shot. Can you fix up these tabs on the left? When you click on documents, the layout or the format is broken. So I'll just grab a screenshot of that with my snipping tool. And we are approaching the 50% mark here as well, 100,000 tokens used. I'm tempted to clear this down. So yeah, that's what I'll do. So I'll onboard the agent of the project again, so I can get up to speed on where we are at. We're at the end of module 2. So I'm saying, can you fix these bugs for me from the module 2 build? And then, so I have my screenshot. So let's copy that in, Alt V, and then let's just keep tracking what changes we need to make. So that's the fix the tabs. I'd like a config interface that's available from the user menu at the bottom left, where there's the ability to select the model and provider. This was in the spec, I believe, but is not in the interface. There are a couple of residual columns in the database that we no longer need around the OpenAI responses API. Can you get those removed? I think they've already been removed from the migration script. There's a real-time issue around the removal of documents from the documents table. So in the documents interface, when you click delete, the document stays visible even though it has been removed from the backend. And then when you refresh the page, it's gone. So maybe real time needs to be enabled. I think we need an interface where we can choose the different models, both for the LLM and for the embeddings. So for example, we currently have an embedding model. I don't know what it is, but I'd like the user to have the ability to change the LLMs and at least set the embedding model. Obviously, once there's data in the table, they shouldn't be able to change it. This config style interface should be available from the user menu at the bottom. Okay, so a few things mentioned there, and I'm asking to use multiple sub-agents just to speed it up. So while it makes those changes, let's actually build out this validation test suite. I'd like to create a test suite that covers all of the features of this application. When new features are built or changes are made, I can get an agent to run through the validation suite to make sure that we haven't broken anything when creating the new feature. So can you plan this out and then also work through the PRD and the plans in the agent plans folder to figure out what features have already been built, and let's create tests for those, along with acceptance criteria on what it means to pass those tests. So at the moment we're using Claude's vanilla plan mode. We don't have our own plan/command. So I don't believe it uses test-driven development as such. But at least if we can build out a validation suite or a regression test suite, we'll be able to figure out whether we're breaking things as we're building newer things. And it's best to do this pretty early in a project because it becomes a monumental task once there's a very large feature set that you actually need to cover. So our bug fixes are nearly complete. There's 4 sub-agents, 4 task agents running at that. And then also our test plan is in progress as well. And it's currently carrying out Playwright browser testing. I'm not touching anything here. And yeah, we now have a settings toggle at the bottom, which is nice. And there's an error showing, so the iterative nature of Claude Code now means it can go and fix that. I'll let that continue to work away. So this test plan looks good. I'm just going to get it to also add these instructions to Claude.md so that for future plans we're creating, we need to make sure that they update this test suite with the new features. Can you build this plan? And then also at the very end, can you update our Claude.md file to provide instructions to future agents that when they build out new features, they need to update the test suite. Okay, so it is now building out the test suite and it looks like my bug fixes are complete. And Claude Code has a habit of creating lots of different services. So you can see here, I have lots of different PowerShell windows. So this is generally bad because if it's trying to refresh the server or refresh the environment, it might not be picking up the right environment. So it's good just to keep on top of these. So I'm just going to turn them all off essentially and start up both the front end and the back end again. Okay, looks like it's good. So let's test it out. The formatting issue is fixed. If I delete a file, it's gone. So that real-time connection is now working. Slight issue on the layout. You know, the user menu is appearing at the top, whereas it's at the bottom there. So we can fix that again. Do we have a config? So yeah, we have our settings. And by clicking that, cool. So we can set our LLM configurations. So, okay, hang on. At the moment, if we start a chat, so we are getting a response back, even though there's nothing set here. So we need to decide how are we saving these secrets. Yeah, it looks like it's saving API keys as plain text in the database, which isn't ideal. And then this must be defaulting to what's in the env file because all of these are set as null. So this is why it is good just to keep on top of what the AI coding models will do, because they will be lazy at times and stuff might not be exactly that secure. It looks like API keys would be stored in plain text in the database, which doesn't exactly seem like best practice. Also, if you look at the screenshot, you can see that nothing is selected here, yet the chat is actually working. So I assume it's defaulting to the .env. Can you implement best practices here around saving of these credentials within the Supabase setup? I might push this into plan mode because I want to see what it's actually going to propose to do. Okay, so I think we have the validation test suite complete. So Claude.md is supposedly updated, which it is, yeah, validation suite. I'll just remove the numbers because that's going to evolve. Okay, so let's have a look. So it's agent validation. So this is our full test suite. Nice. And then fixtures, there's a test document. Okay, very good. Yeah, let's figure out how often we want to run this as well. Because obviously there's a lot of tests here, and this is going to grow into hundreds or possibly thousands of tests. So we just need to be careful about how often we run it, otherwise we're going to destroy our usage budget. The other thing is we can codify some of these so we can just set them as scripts, as opposed to an agent having to run them. Let's come up with a plan on fixing the security issues around the API keys being plain text in the database. So I've opened it up here. I'm just going to copy it and add it to our plans folder. So I'll paste that in there. Actually, let's make one change to this plan. Instead of these being user settings, I'd like this interface at the front end to be global settings. So that way we don't have multiple users setting different LLMs and different embedding models, because then the dimensions of the embedded models would kind of conflict. Can you make a plan on changing the existing user settings and having these as global settings? The idea would be that we might need a user profiles table, and then when a user is created, it automatically creates a profile for the user. We need to assign a role of admin or not. It could just be a Boolean. If the user is an admin, then they would have access to the settings, and then they could set the LLM API keys, all of that stuff, the embedding models. So yeah, let's plan that out. So I'm having an issue where the admin user can't access the settings panel, and Claude Code was spinning its wheels on it. This debug mode is so good on Cursor. It creates these hypotheses, it puts in logging, then you reproduce it, and it's able to narrow down exactly what the problem is. So it actually has identified the root cause here. There isn't, I don't believe, a debug mode or debug kind of slash command in Claude Code. There we go, it worked. Brilliant. Yeah, that debug mode is very useful. Definitely recommend it. And then it removes all the debug information and instrumentation that it used to actually figure out the problem. Okay, so let's test things out end to end. So we'll sign in. And now if I try a new chat, just say hello. This should not work because I don't have any API key set. Connection error. Okay. And then if we come in here to settings, and then I have an OpenRouter key set up. Worthwhile setting this up anyway. Go to OpenRouter, grab an API key, and then I'll just drop that in there. And then the model name, so what model will I use? Let's use the new GLM. So we'll grab that. And then the base URL for OpenRouter is just this. And then for the embeddings, now it's saying there's chunks existing, so I can't set the embeddings. So within the vector database, if you have any chunks set, then you can't change the embedding model or well, you shouldn't change the embedding model. You definitely can't if it's different dimensions. So I'll just delete that document, which should then cascade down to the chunks. If I refresh, yeah, I'm now able to change the embedding configuration. I don't believe there's any embedding models on OpenRouter. Oh, there is. They now have added embedding models. Cool. Let's use the Quinn 3 embedding model. That's doing pretty well on the MTEB leaderboard at the moment. So I'll just copy that out. So that's the model, same base URL, same API key, and then dimensions. Let's go with the 4096. See, does that work? Okay, that's saved. And then back into the chat. Let's ask a question. Okay, there you go. So that is coming through from OpenRouter. That's brilliant. And then for a document, let's just upload our test text file. It's dropped in there. Now that has failed. I'll get Claude Code or Cursor to dive into this one. When uploading a document, I'm receiving an error. I assume it's when it's trying to embed the document. The error is actually cut off, but it starts with this. Could you check log files and figure out what the problem is? Oh, it's a Postgres error. So, of course, the dimensions are hard set in the database. It's probably in the migrations file. Yeah, vector 1536. And we have configurable dimensions on the front end. So we probably just need to change that so that that vector column can support different numbers of dimensions. Okay, I think that's fixed. So it has just removed that specific dimension number from the column itself. It might have had to remove an index, so that might be something we'll come back to in the future. But let's just try this again. Drag that into the box. Okay, yeah, that worked. There's our document. We have our chunks. We have our embeddings, all 4,000 dimensions of them. Cool, so we are now using GLM 4.7, which was only released recently, along with Quinn 3 embedding model, which according to the MTEB leaderboard is better than the OpenAI one. Of course, benchmarks need to be taken with a pinch of salt. And just before we move on, I just want to test our local models. So I have my AI server set up on my network here, and I have Quint3 VL 30 billion, which is a mixture of experts model. And I also have the small Quint3 embedding model. So we have a look here in LM Studio. I'm using as opposed to a Llama. We have various models downloaded. These are the two that I have mounted. So you can see them there. On the Quint3 VL, I've set a context window of 70,000. So, okay, let's give it a shot. So we come into documents, and again, we need a text document. So I've just copied in the text from one of those manuals into a .text file. So if we drop that in there, okay, that was pretty good. You can see the log files coming through, the Samsung electric dryer. And now if we ask a question of it, tell me all about this Samsung electric dryer. Okay, so you can see it's all streaming through. That's pretty fast, actually. Let me try that again. And all of that looks pretty solid based off the text file that I uploaded. So this is the text file that I uploaded. There's only one file in the vector store. We're just testing here, but cool. So yeah, this works locally. As you can see, this is using LM Studio. I'm on an RTX 5090 here. It's 32 gigs of VRAM. So there's plenty of space here for this. And even with the context length of 70,000 tokens, yeah, we're right at the limit of the GPU memory with that. Now, we could decrease the context length if we needed to load more models in parallel, but no, that's all very good. Okay, so let's clear the decks here and let's move on to module 3. And actually, before we continue, we just need to commit everything. So I could get one of the agents to do this. I do have GitHub Desktop set up here, so we can just see what changes are there. So 55 changed files. So this is module 2. From looking through it, it all looks pretty good. The various database migrations. So these are really important that we have these migration scripts. So let's commit all of that to master. And before pushing it, let's just give it a tag. So I'll come into history. There's module 2. Let's create a tag, which is v0.2. So that's the tag created. And now we can just push. And if we have a look at our GitHub, okay, so we can see we have our 2 tags. There's version 0.2. Okay, so there's our version 0.2 release. So bring your own retrieval, a provider abstraction. There was a few extra features we built in at the end. So let's get on with version 0.3 or module 3. Okay, so let's get into plan mode, shift tab, and then let's start planning out module 3, please. So, okay, what is module 3 about? We're creating a record manager because we want to avoid a situation where you can upload duplicate files. And that's exactly what can happen here, right? So this is a file, and if I upload the exact same file again, it will just upload. So now these chunks are duplicated in the vector store. If we come into chunks, we have these 2 files, which is essentially the same file, and we have duplication. So this is going to cause problems when we come to retrieval, because you can end up with a lot of noise in your vector store if documents are going to be duplicated. So we essentially need some sort of hashing algorithm, some way of recognizing that actually the file has not changed. And thinking about it, we're working away at a record manager here, but module 4, metadata extraction, this is pretty much a different feature to module 3. It's quite possible we could run at these in parallel. So yeah, let's onboard our second agent here, and let's see, can we start planning that out as well? Okay, so it's saved the plan. So there we go, module 3, record manager. Let's have a read of it. It's a medium level of complexity, prevent duplicate ingestion, enable incremental updates. So skip processing entirely if it's identical content. If it's modified content, only re-embed chunks that actually change, preserving unchanged ones. I do prefer to delete out all of the old chunks and re-import. I have found that's better because you can end up with orphan chunks depending on what changes were made to a file. So I'll get to make that change. Now we are on accept edits on here, so I do want to just make sure it doesn't actually execute this once it updates the plan. Okay, no, it is actually executing it. So let's just stop that. Just finish making changes to the plan. Don't carry out any code changes yet. Okay, so that's changed. Yeah, so let's clear down this, and we'll use our build / command, and then just drop in the plan and let it go. So on the module 4, for example, where we want to do the metadata filtering, can you plan the implementation of module 4? Module 3 is currently already in progress, and we just need to change this to plan mode. And actually for this one with metadata filtering, I'm just going to really push it to ask me any questions if you need clarification, because I feel like there's a few ways that this could be implemented. Okay, now we're up and running at 2 phases at the same time. And that's kicked off multiple sub-agents as well. So we're burning through tokens. So the metadata planning agent has come back and it's asking me some questions. We'll use the same LLM provider for the moment that we're using in the chat for metadata extraction. On the UI side, maybe we need this expandable detail panel per document. That would be pretty cool. And then on the backfill, should we include a backfill mechanism for documents uploaded before module 4? No, let's not do that. Okay, so our plan is complete. Let's have a look at it. The goal is to extract out structured metadata during ingestion. Metadata stored on documents and propagated to chunks. That's good. Retrieval supports metadata filtering. That's good. So obviously we need a database migration script to add the new fields. We have a pedantic metadata schema for validation. Interesting. So it uses the first 8,000 characters of the document text. I think that's probably a smart move because some documents could be absolutely enormous and we don't want to burn through API budgets. So this model is a key part of it. We need to define this depending on what metadata we are trying to extract. Looks like a good plan. My question is, where can we define the metadata keys? I'm wondering, should we create an interface where the admin can actually add metadata rows basically, and then I'm sure we're going to need required, not required, or the data type as well. What do you think? Meanwhile, it looks like we're finished on the left-hand side. So we have our content hash, the record manager service, the upload endpoint with deduplication. So let's test that out. I've seen Playwright and Claude Code automatically testing and validating some of this, so at least it carried out that. So we're mostly doing a smoke test here. Okay, so let's refresh. And now we can just try to upload this exact same file again. So document updated reprocessing. That's interesting. It definitely wasn't updated. Or maybe it was. Document unchanged, skipped processing. The content hash hadn't saved initially. That's what it is. Okay, so that is working. If we refresh here, yeah, we can see the content hash. Cool. And I'll just test by uploading an additional file. Perfect. Yeah, that uploaded fine. And that was a new file. Okay, so then on to the questions from the metadata. So it's saying how configurable should this be? Yeah, maybe database store. That's a good idea. Let's not over-engineer this. So we already have a global settings table in the database. So maybe we just have a field, which is the JSON. So I'm happy with that. I don't want it hard-coded. I think it'll be nicer if it's in either the database or the admin UI. If we go dynamic, what field types should be supported? Yeah, let's go for the full list for the moment. So let's submit those. Okay, so the plan's updated. Let me just copy that into my plans folder, the new changes, and saved in the global settings. Perfect. So let's get out of that. This is done as well. So we can just clear both of these now. And now let's jump into our build / command. It's rinse and repeat, really. Drop in the link to the plan and let's go. So after this is finished, we'll commit everything. And then this could be our next release, which is a mixture of module 3 and module 4. Cool. So it looks like we're finished on the metadata. So let's have a look here. I'll just refresh. And let's just drop back in that text file. And you can see it's processing. And then it loads up an LLM generated title and a summary, as well as applying a document type and topics and a language. So really cool. This is using a local model as well. So that's class. And then that metadata schema is actually within the global settings of Supabase. So we have this metadata schema and it describes exactly what can be in these fields. Now, this can cause problems when it comes to actually fetching responses. So let's come back into our chat. If I ask the same question again, tell me about the Samsung electric dryer. Yeah, I don't have any specific information about the electric dryer in the documents provided. I think it's just being overly conservative with the metadata filters. So if we come into LangSmith, and this is why it's really important to see the tracing. And if we come into the latest one, which is this one, you can see that it triggered this search documents tool, which is our RAG tool. So if we ask the same question again, tell me about the Samsung electric dryer. When I test this out on the front end, I am getting an error when the vector store is being searched. So I'll just paste that in. We are hitting over 50% of the context window again, so I want to clear this down soon. It's a database error from the duplicate database functions, not actually the agent having duplicate function calls. Okay, there we go. So it is working. Great. So that has fixed that. So this is just bug hunting at this point. We can stop that there. So if we're looking at the traces here, I can see that the AI triggered this search documents tool, which is our vector store. It passed in a query of Samsung electric dryer. So it didn't actually pass any metadata filters. So it wasn't actually being conservative. What can happen though is it can get overzealous with the metadata filters to the point where it doesn't actually return anything. So this is where your system prompting really kicks in. You need to describe to the agent what metadata filters to pass in what particular circumstance. And in reality, looking at these metadata filters, You might want to filter by topic, for example. So let me try that. Let me see what topics are associated with this document. Smart home integration. So let's try that. And I'll just be specific in this prompt because I don't have the system prompt set for the agent. Can you search the documents for anything got to do with Samsung refrigerators? But I want you to specifically narrow this down to the topic of smart home integration. Now I couldn't find any documents. Document type was article is what it passed. Yeah, document type is reference. So that's why it couldn't find anything. It did get the topic correct, which is smart home integration, but it picked the wrong document type. So then as a result, it completely ruled out all of the chunks about this document and it returns nothing. So that's something that will, number one, need to be prompted around. So we'll need to update the prompts of the agent. But number two, you just need to be very conservative and cautious when it comes to setting metadata filters to avoid a situation where 0 results are returned. Okay, so we're pretty much done with this feature. So let's clear this one because it's over 100,000 tokens. Can you create a git commit for everything that's outstanding? Check module 3 and 4 in our PRD and plans 7 and 8 in our agent plans folder. This is essentially what has been worked on that needs to be committed. And there's our release. Excellent. Okay, on to module 5 now that we've pushed that release. Multi-format support. The big one for me here is PDFs. So we're going to use DocLing. That has both a standard pipeline and a VLM pipeline. We could also use Mistral OCR, and that would just be a simple webhook or an API that we would hit. But I really like DocLing because it gives you a lot of flexibility. So we'll just do the usual, clear down, onboard, and then ask Claude Code to create a plan. Let's kick off the planning for module 5, and let's focus on installing DocLing. Let's not support unstructured or Mistral or any others, just DocLing. And I'll change that to plan mode. And while that's working, let's also plan module 6. Like these aren't necessarily related features. One is about ingesting different file formats. The other is about implementing hybrid search and re-ranking. And a few questions. So which file formats should module 5 support beyond the existing text and markdown? I'm just going to say whatever DocLing supports, essentially. DocLing requires PyTorch as a dependency, which is large, around 2 gigs. It also downloads machine learning models on first use. Are you comfortable with this? So this is a good question. I think I probably will download it to this laptop. So this is a gaming laptop that has 8 gigs of VRAM. That should be enough to run these smaller machine learning models. For the VLM models within DocLing, I'll use my AI server that has 32 gigs of VRAM. Okay, and then PRD mentions cascade deletes. Currently, there's no delete document endpoint or storage cleanup. Should we add a delete document feature? So I think that might be incorrect. There actually is a delete document button in the front end, and that does actually delete the records, the chunks, and the files from Supabase storage. So I believe this is already implemented. Okay, let's submit that. And I've hit my rate limit, which unblocks in 5 minutes. So I'm going to get a cup of coffee. Okay, so coffee, well, tea actually. So let's kick it off again. We're currently building out module 5. Can you plan out module 6, please? Okay, so that plan is finished. So multi-format support with DocLing. So complexity medium, focus change to 1 pipeline stage, which is text extraction. Max file size 50 megs, that's fine. And then just update the front-end component. I think that's all good. That's clear. And then straight into build, and away it goes. Meanwhile, I think module 6 is almost finished in planning. So it's really now just a production line of planning, building, testing, and bug fix. And it looks like it's downloading those models now. Okay, so here's our plan for module 6. Let's open it up and let's bring it into our plans folder. Okay, so we're talking about replacing the pure vector search with the hybrid search pipeline. So keyword, full text search plus vector. And then we're going to have reciprocal rank fusion and optional re-ranking with cohere. I would like a local option as well. Cohere makes sense, so people can put in the public cohere API and an API key. I would like the option to run a local re-ranking model as well. So we just need to be able to set the various credentials, particularly because the Quinn3 re-ranking model is supposed to be pretty good. Okay, so those changes have been made. Just paste that into my plan that's in the folder. So we'll escape out of that. Let's clear the context. We'll go into edit mode. Then we'll use our build / command, drop in that module, and then let's go. Cool, so hybrid search is done. I think the other one is done as well. It's just working through the validation tasks. So I'll let that continue, and then I'll just test out the hybrid search and re-ranking. So we now have a lot more documents supported. So let's drop in that one. So it's processing, and that has completed. So yeah, we have 5 chunks. We have all of the LLM generated metadata, and that's in the completed status. And we have our chunks there as well. Brilliant. So that section is working. And let's ask, explain to me what the water supply situation is for this product number. Cool, yeah, there you go. So it's pulled it out of that document, and we are using Qwen3 VL30 billion. So that's a pretty good answer, actually. Excellent. And that is the module 5 multi-format that we're testing there. Module 6 is hybrid search and re-ranking. So let me come into settings. So we have our re-ranking configuration here. Must not be enabled though, because we got an answer back and we don't have an API key set for Cohere. So let's get an API key very quickly, and we'll test out a local re-ranker as well in a minute. So there's the API key. Okay, let's save that. And let's ask the same question again. We definitely need to figure out some logging as well. How can we verify that there is actually re-ranking going on here? I think it's in LangSmith. So let me go into that. Yeah, so this was that message that I sent. Explain to me the water situation. We got that answer back. Search mode hybrid. And we can see in the tool call, yeah, re-rank 0.75, RRF 0.1, similarity score 0.47. Excellent. So we have re-ranking working. And if I compare that to the question I asked a few minutes ago, before I set the API key, exactly, we only have RRF there and similarity, whereas when re-ranking is enabled, we have re-rank RRF and similarity. So perfect, I think that works. So I could do a lot more testing on this, but in the meantime, I'm just going to commit everything. So I'll just get a new agent up and running. So let's just clear this down. Can you review plans number 9 and 10 in the agent plans folder, and then commit everything that is outstanding, create a new tag called 0.5-0.6 using the same convention, and then create some release notes, and let's get all of this pushed up to GitHub. Cool. So we'll let the agent do that. Okay, so version 0.5 to 6 is now up on GitHub. We'll be doing a lot more thorough testing of this as time goes by, but these quick smoke tests are working well, and obviously the LLMs are doing verification as well. Okay, so let's test out how fast this ingestion is before moving on to the next phase. So I've got nearly 200 files here. Let's just grab a handful of them like that, drop them in, and let's see how it works. So a little bit slow, they are streaming through. So it definitely could be faster. Of the 16 files I uploaded, they're kind of coming through one at a time. I know in DocLing there's an async mode that you can use. So it might look to see, can we use that to try to speed this up? You can see all of the completed ones there. All right, we're nearly completed. I get the feeling I might be maxing out on my resources though, because my computer has slowed down quite a lot. So I'm at 92% of my RAM. So this is definitely down to running the machine learning models for DocLing on my laptop and then loading in lots of files in one go. It possibly has spun off lots of asynchronous processes. I will have a chat with Claude Code to see how I can make this leaner and also make it faster as well. Maybe it is worth offloading these processes to my main server. Now you can always use cloud document parsing services like Llama Parse, or OCR services like Mistral, or the likes of Data Lab OCR. So there's lots of different options here if you didn't want to do this locally. But if you do want to do it locally, you will need to make this as optimized as possible. And you can see of that memory usage, Python is using about 8 gigs of that. Actually, I have DaVinci Resolve open. I might just close that and save some space. Yeah, things are starting to look a bit better. In the meantime, definitely worth seeing with Claude. Is there any ways that we can make this leaner? So let's just have a chat. Can you check out the document ingestion process and flow to see, is there any way that we can make it faster and leaner and make sure that we don't max out, server resources? Okay, so let's let it run at that. And in the meantime, let's have a look at module 7, which is the additional tools. So here we're looking to build a text-to-SQL tool. So for querying structured data, have a web search fallback, because we are building an agentic RAG system. It isn't just vector search. We want to have lots of different tools. And in future, we will also provide code access so we can actually execute arbitrary code in a sandbox. We won't do that in this video, but we'll do it in follow-on videos in this series. Can you create a plan for module 7 based off the PRD? Okay, so it has provided an analysis. And there does seem to be some issues here. So it seems to be loading the file twice into memory. There's no concurrency limits on the background tasks, so it could spawn unlimited background tasks, which could crash the computer. Let's go with those 4 recommended optimizations. And also, can you just document this in the agent's plans folder, please? And trigger multiple sub-agents to speed up this process. So our performance improvements are finished. So let's test them out. We need a delete all button here to make things faster. So we can add that to the backlog. I'll just do it in the Supabase. So I'll just select all documents and delete, and then back into here. Now, maybe I should restart the server actually, just in case. So let's do that. Okay, just stop everything and start up again. Possibly not required, but no harm, just in case. Okay, and let's drag in our files. So they're all getting added. Yeah, they're now in that pending state I was kind of hoping for last time. And let's keep an eye on our task manager as well. Yeah, so it's definitely faster. The fact that a lot of them are staying in pending definitely proves that it's actually loading them in batches now as opposed to shoving them all in at the same time and crashing the server. It definitely still could be faster though. I would like to figure out where the bottleneck is in this pipeline. Is it in the LLM calls or is it actually on the DocLing side? And then also we have 3 that are still processing here, let's say, whereas lots of them are pending. So what is our batch size? There always seems to be 3 in processing, and that's a constant here. Max concurrent ingestions is 3. So we could change that. And I can't hear the fan spin on the server, so we're definitely not maxing out on LLM calls here. Let's try to set this number to 10 and let's run it again. So I'll just delete out everything. And now with 10 set, let's try it again. Okay, going again. All right, and they're processing. And you can see the fall off in both CPU and memory when I turned off those jobs. And on the graphics card side, we're fine as well. So resources are okay. Yeah, so it is slightly faster, but it's nowhere near as fast as it needs to get to. So there's a few iterations of this needed and diving deep into the DocLing library as well to figure out what exactly is going on. In the meantime, I'm going to move on to the next phase. This is a project we're going to be building on over the next few weeks and months. So we'll definitely get to the bottom of that side of it. So on to module 7. So we have our plan. Let's have a look at it. So it's a medium complexity, adding multiple new tools with established patterns. So text-to-SQL, predefined query templates, not raw SQL, allowing LLM to generate arbitrary SQL could expose users' data, sensitive tables, or enable destructive queries. Solution, implement a query documents database tool with predefined parameterized query types. So list documents, get document stats, document search by metadata, chunk count by document, recent activity. So this is very much up to you, whether you want to use these blueprints, these parameterized database queries, or whether you want to allow kind of raw SQL generation, but actually lock it down at the user level. So it's only a read-only user. So even if it tries to delete the database, it won't have access to do it, and that's controlled at the database level. So for this text-to-SQL, instead of going down the parameterized query route, I might just give access to read-only on one table. I'll create a specific user for that. But you definitely could go the query templates route. It's a very good pattern to use. On the web search, we'll use Tavily. I'm happy with that. On the text-to-SQL, instead of using query templates, I am happy with raw SQL. However, what we're going to do is create user accounts, database users that have the permissions locked down. So let's say we only have a single table. We're not giving access to everything in Supabase here. Instead, we're just going to create one new table in Supabase, and we'll call this, as an example, order history, let's say. And then I want to give this agent access to this table, but only read-only access. So if they try to create raw SQL to delete the table or access other tables, it won't be allowed by the database. Alan has created a video on SQL agents where he goes through lots of different design patterns. Here I'm just using text-to-SQL, for example, whereas in that video he also goes through other patterns like creating views if there's complex data tables and highly normalized tables, or creating query statements like what was recommended here. I'll leave a link for that on the card above. And that's our updated module 7 plan. So it's a raw SQL with database level security. So let's clear down the session and let's use our build / command, and we'll provide a link to that plan, and let's kick it off. And that's up and running. So on to module 8, which is sub-agents. So I want a situation where within this RAG system, if we find a chunk that is interesting, we're able to ask a sub-agent to load up that entire document into its context and extract out any relevant insights based off whatever the query is. So a problem with RAG systems is that a lot of the time they're building out answers off segments or snippets of a document, and they're missing the full context of the document itself, or of sections or categories. So a nice pattern is for a sub-agent to be able to load in the entire document. With all that loaded into context, they can extract out answers. But you don't want to load these documents into the main agent. Exactly the same as here. Like, we are very cautious about going over 50% of the context window here. Yet these agents are triggering sub-agents to go off and build things or to explore or to test. So within our own RAG system, we want to keep our main agent focused on answering the user's question, and it can spin off workers to go and do some research. Let's create a plan for module 8 within our PRD. And I'll go back into plan mode because I'm actually in edit mode here. Now this could be a big one because it's actually talking about having nested tool calls displayed in the UI, as well as showing reasoning from both the main agent and the sub-agent. So this could get kind of complicated from a front-end perspective. And while that's building out, it's worth exploring the code base. And again, even if you're not a coder, just to get a sense of where everything sits and how everything fits in together. So here we have a backend and a front-end folder, which makes sense because they are totally separate systems, one on Python, another on React. We have a scripts folder, which is what we're triggering when we're restarting, stopping, or starting the servers. There's a Supabase folder, which is mostly for migrations as well as a bit of config. And then we have our AI code editor folders, .agent, .claude, .cursor in this case. There's also a playwright MCP for browser testing. Within our front-end section, we have this node modules folder. So all of the Node.js modules are loaded into this area. So it's essentially like a localized environment. We have public, which are any of the assets that we need to render publicly. And then there's source, which are the source files that build out the React application. And then that's all broken into components and hooks and pages and types. So you can have a chat with an agent in the likes of Cursor here. You can ask it to explain what's in all of these folders and how it all fits together. And the same with backend. So we have a virtual environment. We have an app folder, which is broken down then into the likes of models and routers and services and the database layer. Again, chat to the AI to figure out what all of these things do, because the better mental model and mental picture you have of how this works, the more likely you're able to keep it on the rails as you keep adding new features and fixing bugs. So module 7 is now finished, and we have our module 8 plan as well. So let's not kick that off just yet. Let's open it up. And let's just save it into our plans folder. So this is number 13, module 8. Our module 8 plan is complete. So let's have a look at it. Sub-agents implementation plan. So this is complex as I thought it would be. Multiple phases, changes across backend and front end. So add hierarchical agent architecture where the main agent can spawn isolated sub-agents for full document analysis. When a user asks to analyze an entire document, such as summarize, review, extract key points, the main agent delegates to a sub-agent with isolated message context, document-specific analysis capabilities, streaming, reasoning visible to the user. And then this will be triggered via a new analyze document tool. Cool. We could kind of make this broader and less specific to full document analysis. So that's one thought that jumps to mind. But for the moment, let's leave it at this. We can always try to generalize this a bit more in the future. And the agents have other tools anyway, like web search or text-to-SQL now. Yeah, I think I'm happy with this. Let's kick it off and let's see how it goes. It's quite a big change. It might need a couple of phases. Are there elements of this plan that could be executed in parallel? Yeah, I think there is. So parallel execution opportunities. Yes, please update the plan with this. So yeah, mostly back-end work and front-end work could run in parallel. Okay, so that's done. And let's not trigger it just yet. We'll copy this into the one that's in our plans folder. So these are the parallel waves of the build. So let's clear this down because we've got 36% of our context used already. So let's start it from scratch. And then let's trigger our build / command and drop in the plan, and away we go. Cool, so let's carry out some manual testing now on module 7, which are the additional tools. So let's just restart the servers. I've got all of these command shells opened up, so let's just close them all. Okay, nothing running, so let's start again. And actually this is incredibly bright, so let's implement a dark mode here. Can you implement a dark mode on our front end? And have it as a setting from the user menu at the bottom left. Okay, so we have our documents, we have our chat. Now let's come in here to the database. Because if we want to do text-to-SQL, obviously we need a database. And we have it there, sales data. So it has created some dummy data, that's perfect. So let's test it off the back of that. So what can we say? What's the total value of all orders placed by the Metro office? Okay, so checking the sales database. Now it has come back with this. So let's go into LangSmith and see, has it actually called a tool or did it just hallucinate that? We are using Quinn 3, our local 30 billion mixture of experts model. So you can see the tools that are available. So query sales database is there. And yeah, it did use it. So select some total amount from sales data where customer name equals Metro Office. And it shows that the query returned 12 rows. So from looking at the sales data in Supabase, it does look correct. So Metro Office, 25 units, 1124. So that's correct. And then the Keyboard Pro, 30 units, 2399. That looks correct. For some reason though, in LangSmith, we can see the SQL query, which is there, select a sum of the total amount. So if I just run this against the table, so let's come into SQL editor, if I paste and run, I'm just getting a single value, 3524, which is that. So this breakdown, where is this coming from? So if we can trace exactly what happened here. So we have the input, so this is our system message. We have the question I asked, and then it hits the query sales database tool. It passes in the SQL query it wrote, and then this is the tool call response. So query returned 12 rows. I don't understand why that happened, because when I run the query myself, I'm only getting a single row. So I do wonder, maybe it's hard-coded something in the back end. Let's copy this out and see. And we can see Claude Code is auto-testing new features here as I investigate this one. So this Claude agent that built out module 7, this is the one that built the text-to-SQL tool. It's at 72% of its context window. So we definitely need to clear this down. So let's just clear it. How are we on usage? We use about 50% so far. Okay, so let's onboard again, because best to have an agent fully up to scratch on the code base before we get it to try to bug fix. I just asked this question on the front end. However, I can see in LangSmith that the response included the full table as opposed to the actual sum which was in the query. Here's the example. Why did this not produce the actual sum, a single row with the sum? Maybe it's hard coding some query, for example. It looks like my dark mode is finished. And it also looks like module 8 is finished and verified as well. So we can test that out too. Let's come back into here. Okay, so there's dark mode. I think we need to update our logo to have a dark mode version of our logo. I've just dropped in a dark mode of our logo in the front end public folder. Can you apply that, please? All right, and that's working away. Now let's have a look at what happened in this query. Yeah, there you go. There's a fallback within the script that ignores the query entirely if it fails and just does a select all on the whole table. So it's deliberately returning all data. We definitely need to get rid of that. Ah, the migration file was never applied to the database. Okay, so let's try that again then. I'll just copy out that question, back into new chat and paste. I'll check the sales database. No, it didn't. Still just getting all rows. So I think it's an issue around the locked down user. So having a role that only has read permissions on a single table is the issue. So fix the execute SQL as reader function. Let's just go to Supabase and let's look at the database functions. Execute SQL as reader. Why do we have a database function for this? Is this simply not a case of creating a new Postgres user that only has read access to this table? Is that not it? So I might be trying to over-engineer something here. And it's proposing something different here that I'm not necessarily convinced by. Surely what you're proposing means that the LLM could delete all data in the table. Yeah, you're completely right, and I was wrong to suggest relying on Python validation alone is the solution. Yeah, so it's just dedicated Postgres user with only select access on the sales data table. That's all I want. Stop over-engineering it. Okay, let's implement that. And you can kind of see how a code base can go off track fairly quickly. And this is just a perfect example of it. Like here it was creating database functions and using RPC and essentially was creating a system that was highly complex and actually doesn't even work and doesn't actually have the security that we need. We need this to be enforced at the database level. So what I was thinking about that, let me get a Tavily API key so we can actually try out the web search. The alternative to Tavily is search engine. This might be a better approach, seeing as we're doing a lot of things locally here. I'll leave it at Tavily for the time being because it's a simple API key. But this is definitely a good system to use and it's a local way to access search results. Okay, so I'll just copy out my API key for Tavily, drop it into the env in the backend. I'm not seeing it in the env example in the backend folder, so I don't know the exact key name we're looking for here. So you can search the code base on the top left with the search icon. So there's Tavily, so fullsuite.md, websearch.py, Tavily API URL. Where's the key? Settings API key. Oh, on the settings page, of course. So it's not an env, it's down here. We could arguably just put it into, there we go, enable web search. Oh yeah, a provider dropdown as well. So you can decide where it makes sense to save things in likes of a settings page like this where a user can change it, or where it makes sense for it to be set in a .env file. I think arguably this probably makes more sense in an env file. Anyway, it doesn't really matter. We'll save it here and let's see, does it work? Okay, so web search is enabled and this agent has finished on the SQL, the text-to-SQL. So create the read-only user and clean up the broken RPC function. All right, so it's asking us to run some SQL in the Supabase database. Yeah, let's do that very quickly. So let's just drop this function. We could, of course, get it to do it too, but no harm us getting our hands dirty a little bit. So let's drop the function. Yeah, we already have sales data, so it's not letting us drop it. Okay, fine, we'll get it to do it. Can you make these changes? It is asking us to create this env for the SQL reader database URL. That's the direct Postgres connection. So we will do that. And then we need a password for this user. So I've just got a password here, so we can drop that in. So I'm just saying, can you make these changes? I've added the SQL reader database URL and I've added a password for that user into that string. Now, Claude is looking for the password for this user. So I can either give it the password or just run this myself. We have Supabase CLI set up and you should have full access to our Supabase system. Please trigger this yourself. It's getting very lazy, unfortunately. Okay, so that is the dark mode and light mode working with our logo. So that works pretty well. It seems to be struggling with this Postgres connection. So I might just stop it for 2 seconds. And I might come into the connect section of Supabase because this has a lot of the information that's needed. Now you could direct connect or use the transaction pooler. What should we do? Let me think. Let's use the transaction pooler actually. This is what we have set in Supabase for the Postgres connection. It was hitting the wrong port. Okay, just need to update our connection in the env. It was trying to hit 5432 and that's actually 6543. Okay, let's reload the backend and I'll get it to continue validating. Okay, so security is now enforced at the database level, and I just saw that it tried to delete from the table or delete from other tables, and it couldn't. Let's test this out again. So new chat, total value of all orders placed by the Metro office. Checking the sales table. Total value is 3,524. Then into LangSmith. Okay, what's the total value of all orders? There is the SQL. Excellent. Query return one row, and that's the row. Perfect. Can you give me a breakdown of these orders? Cool, that worked. Perfect, yeah. So select the product name, quantity, unit price, where the customer name equals Metro Office, order by order date. Brilliant. Yeah, so that's working pretty well. Nice that you can see the tool calls as well. So let's try another one. Give me all order data. So you can see querying database. Very nice. 12 orders. And we have 12 records there. Excellent. So that's our text-to-SQL up and running. There's so much more you could do with this. I'll leave it there at this point. But you could definitely take that a lot further. Now, it's a simple table, so obviously you can have a lot more tables and things get a lot more complicated then when the tables are normalized. So in a lot of cases, you might need to denormalize them by creating views and just make things a little bit easier for your agent. But you get the idea, that works pretty well. So let's test out our web search. Can you search online for the latest weather in Galway, Ireland? Okay, searching the web, as you can see there. A little bit of a rendering issue here. The search bar has gotten very big. I've reached the context window length of 4,000 tokens on my local model. I did have that set higher, but then I restarted the server, so I need to just change that. But anyway, you can see that it worked. And if we go into LangSmith and have a look at the tool call, that's that one. So you can see the full back and forth. There's the order data, web search, latest weather in Galway, Ireland, and Tavali has provided all of this back. Excellent. That's our Agentic RAG up and running in terms of having a vector store, having a structured database that we can use SQL queries, and having web search. Let's now test the sub-agents, because that was this agent here, which is now finished and verified. So let's test it out. Because of the documents that we've uploaded, let's try to find a big one. This one is 3.5 megs. Yeah, that's 38 pages. So let's ask it to maybe summarize the Haier 24-inch built-in oven, and we'll pass this product code. Oh, this weird styling issue is because we have too many chats. Okay, I've reloaded that model with 70,000 tokens of a context window, so that should be enough. Can you give me a summary of the Haier built-in oven? Here's the product code. Okay, let's see how it goes. I'll check the documents to find information. So it's searching the documents. Couldn't find any documents about the built-in oven. I really need to fix these formatting issues because it keeps popping down. Okay, that front-end fix is now complete. So the scroll bar on the left stops at this point. So the user menu always appears, and that should hopefully fix our issue with the chat. Let's jump into LangSmith and see what happened here. So back into LangSmith. So the summary of the built-in oven, it did search documents. Nair built-in oven, HCWW. The metadata filters are killing us here. It set document type as product spec and gave topics. It's just been overly conservative. What's the best thing to do here? So I probably need to just update the system prompt and to guide this model a bit better and how to use these tools. So let's see, where is our system prompt? So backend, app, models possibly, services, LLM service. Okay, so this is our system prompt. You are a helpful assistant for the RAG masterclass application. You have access to multiple tools. The available tools are these. Okay, so I'm just going to say, for the moment, do not use metadata filtering. Search modes, hybrid, keyword, or vector. Yeah, we'll leave that for the moment. And there's the analyze document sub-agent. I think we need to just describe how it's okay for the agent to essentially execute a retrieval strategy so that it can use multiple tool calls to actually get to the response. So I might just use cursors agents for this one. Within this LLM service Python file, can you update the system prompt around the tool call usage? I want the AI agent to essentially generate a retrieval strategy to answer the user's query and then execute against that strategy. And if that means multiple tool calls to the search documents tool or to querying the sales database, so be it. So this is really where the agentic side of it should kick in, because we want the agent to be able to work through tool calls progressively and build up a view of the data, similar to the way Claude Code does it in the code editor here. Now we are using a much smaller model. It's a 30 billion mixture of experts model, so there's arguably only 6 or 7 billion parameters in play at any one time. This might be kind of at the edge of what these local models can do. Okay, let's keep that. Develop a retrieval strategy and then execute it strategically. Let's just restart all services because these changes to the Python files may not kick in if I don't. Okay, and we'll try this one again. And we got a Supabase error. So it did carry out the search, a hybrid search with the product code and Nair. So that should have produced the right document. And it did actually, a 24-inch built-in oven. And then it triggered the analyze document tool call, and it passed the document ID, summarized the Nair built-in oven with the query. So actually, this is exactly what we wanted from this main agent. So what happened, our sub-agent? This is probably where this error came in. Postgres couldn't retrieve response, please check. We'll copy this code and let's see, can Claude Code get to the model over this one? In fairness, this is pretty complex functionality, so I'm not surprised that it didn't get it right first time. And this is the agent that built this feature, and it's nearly at 60% of the context window, so I'm tempted to just start from scratch here. I'm currently manually testing the functionality built in Module 8. I'm encountering this error message in a chat that is triggering the sub-agent. Can you see what's going on with this? So there's the message. I won't plan just yet. Let's see, can it actually figure it out on the fly? The one thing that jumps out to me is logging. I think we need a lot more log files, debug files to actually get to the bottom of certain issues like this. And LangSmith is great because it's a very visual way to figure out how the tools are being called. But something like this, where it's an agent within this code base communicating with a sub-agent within the code base, all of that is locked in the code base itself. So we need some visibility on that. I don't know which direction this is going down now. The error is coming from the Supabase Python client when using maybe single with the query that returns no results. The 204 status code means no content, but the client is raising it as an exception instead of returning none. Okay. I have no idea, maybe. I'm definitely not committing to Git enough as well, because I feel like we may be going down the wrong path with this. And if we were committing to Git kind of a lot more frequently, it would be easier to roll back. Let's see though. Okay, it's made those changes. Let's test it out now and see. So back into here, new chat. So searching documents. So that's our RAG, that's our vector search. Looks like there's 2 calls happening. I need to fix the formatting of this because these should appear obviously below. And when one is finished, it doesn't need to keep appearing. Yeah, so this one looks like it's failed. Let's track it. So we have got the right chunk back, and then tried another query. I don't know why it didn't try to trigger the analyze document tool. Let's try it again. I've grabbed a screenshot of that as well, because it's not supposed to render like that, obviously. We're getting some strange rendering issues on the chat interface around tool calls, as you can see in the attached image. Can you fix this up? Because it should obviously be progressive. Yeah, it doesn't seem to have a tool call complete event, so it's going to implement that. Okay, that's fixed. So at least we are now seeing a green tick mark when it is complete. Still should be showing below. I wouldn't mind also seeing, what is actually being searched. We need a little bit of transparency here, similar to what you have with kind of Claude and ChatGPT, and then they all just disappear. So still some front-end bugs to work out here. That seems to have worked in the sense that I have the green tick when it's complete. However, the tool calls are still showing above the first message from the agent. I'm just looking at how Claude renders this stuff. So you can see there's the tool call. You have different steps as well. So they have nested steps. And then obviously this is the thinking mode of the LLM. I'll take a snap of this and just try to reproduce this type of interface. Can we try to reproduce this type of layout? I don't know is thinking mode enabled with this agent. If it is and we're getting think tags back and a thought process, we could render it in the bubble as you see here. But then all of the tool calls, they're grouped like this. You can see the results of the tool calls as well. Can you even look at the attached image and let's try to recreate this. Okay, let's see, can we get this sub-agent working? I have Claude working on this layout so we can have it a little bit more like a standard LLM chat with kind of thought process and tool calls. Let's grab the file name and let's just ask, can you trigger the analyze document tool past this file name and ask to provide a summary of the file? So this should definitely trigger the analyze document tool, and it has. Okay, document not found or not accessible. So that's probably what our issue is. I'm not sure why it rendered like that, but we can figure that out again. So document not found or not accessible. So let's have a look in our documents. So the file name is there. So it's saying I can't access the document with that ID. So we can see it is triggering the analyze document tool. It's passing the document ID and a query such as summarize. Sorry, it's the name, it's the file name. Ah, that's the ID. Yeah, we need to map it to the file name because that's in the metadata. So if we look at chunks, the chunk metadata has file name. I'm now getting this issue when I'm trying to trigger the analyze document sub-agent. I think we're mapping to the wrong field. It should be file name as opposed to ID. Does that make sense? Okay, that's that one. Now I think the UI updates have finished, so let's have a look. What's the weather like in Galway? So we have thinking, I'll check the weather. Okay, yeah, kind of worked. The steps should have stayed where they were, so we can show and hide. That's good. Current weather in Galway, no results, doesn't make sense. So that kind of worked. The steps now shows, except they flow to the bottom. They should appear where they were in the sequence of the actual inference. So they should appear underneath the first sentence in this case. Okay, so that's working away. Let's go back to our other bug. Let's copy this. And let's see, can it analyze the document? And no. Oh, I might need to restart the server. Let's let this one finish first. This is why it actually makes sense to use a git checkout or to use git work trees. So that way we can have a clone of the code base. So that way you can work on bugs in this case or features in parallel without the agents tripping each other up by restarting the server or making changes to the same file. That's something we'll definitely look at in the next video around deployment and then also making changes and then how do you check out and commit those changes. Okay, let's try it again. No, still getting this error message. So it's just an issue with the prompting. Okay, let's try it again. And it has possibly completed. One step completed, results found. Okay, so we're getting a different Postgres error here. Could not find the table public document chunks in the schema cache. Now it's a different error. So it's definitely not document underscore chunks. That's some lazy coding by Claude. So this is why plan mode makes a lot more sense. And it's also why having a verification loop makes more sense so that you don't need to be the one to actually provide the feedback. It should be able to do it itself. So that's something that I probably could lean a bit more on and step out of the way. So we do need a loading section there. Okay, yeah, that has worked. Excellent. And fast as well. This model is incredibly fast locally. Now we have lost all of our tool calls, but it is working, which is lovely. Can you check out the attached screenshot? All of the tool calls are showing and rendering really nicely, but then when the agent is finished, they all disappear. I think Claude is realizing that this is more complicated than it initially appears, because essentially we need to save to history the tool calls if we want to be able to track back up through the conversation and see previous tool calls for previous messages. Okay, so let's see, does it disappear this time? Nope, still there. And now I'll just ask a follow-up question. Can this appliance be used outdoors? So again, it's going to a tool call. No, this appliance cannot be used outdoors. Context window length. I thought I increased that to 70,000. Actually, it was set to 4,000. My server restarted without me realizing. So just reloading that at 70,000 context window. Yeah, we still have a little bit of breathing room on the GPU, so that's fine. Okay, so let's ask that one again. Can this appliance be used outdoors? And cool, yeah, we're not getting those issues. We are getting these steps through. I don't know which tools they're calling, so I might get the UI updated so we can see what tools have been called. We also haven't got a response back. Yeah, the output was a tool call, the search documents tool. And one thing I've noticed as well is that when you go through the different conversations, you can't see those tool calls. So the tool calls do seem to just live in the actual session itself as it's been built out. In reality, I think we probably need to save them to this messages table. So I might open that up as an issue essentially and get the Claude Code to go and fix it. Yeah, I'll do it on this thread just because this is the one that has built out this feature. That's working pretty well now. It would be good to actually have the name of the tool that has been called. It's not obvious from the tool calls. Secondly, when I go to an older conversation, if I refresh the page, let's say on the existing conversation, I lose all of the tool call information. So do we need to save this to like the messages table in the database? Yeah, looks like you're going to save everything now to a JSON-B in the messages table. Is there any way to enforce the LLM not to end on a tool call, that it needs to at least output a response? I've seen examples of an LLM where it just finishes on a vector search and it doesn't do anything with the retrieved data. Interesting. It looks like there's a max tool rounds of 3. So we definitely need that as a kind of a configurable parameter. And there's another option here, which is to force a final LLM call without tools. In the situation where the tool was the last kind of action of the LLM, you could do another call just to synthesize an output. How about this? Let's set that configurable tool call limit to 10. But then also, can we have a dynamic element to the system prompt, which basically tries to force the LLM to output an answer before it hits that limit, and just reference the variable in case we change the number. It's funny, I do like using Cursor's AI agent as well as Claude Code, because for things like that, you can kind of just ask it questions of the code base. Whereas with Claude Code, you end up in like kind of a multi-step, multi-round agent interaction. At times, if you just want to chat to the code base, the Cursor agents are quite useful. Okay, let's try this out again. So can you trigger the Analyze Document tool for the particular ID? Now, so we can see it's Analyze Document. That's great. We are getting an error here. I'd say the Supabase migration wasn't pushed. And it's interesting, anytime there's a Supabase migration, the agent can never push it. It can never figure it out. I think I need to add some information to Claude.md about this. It never seems to realize that it's a remote setup, not a local setup. It doesn't ever realize that the Supabase CLI is installed. Can you do this? The Supabase CLI is installed. It's a Supabase remote implementation here. Can you review the Claude.md file and just make sure that future Claude Code agents know how to actually carry out Supabase migrations? Okay, so let's test this out again. I think the backend has been refreshed. So we've triggered the Analyze Document, passed the ID. We have got the document back and all of that is great. Now, if I refresh, so we can see that this was loaded. We are no longer seeing the nice thought process that we saw. So that might be something we could add. We'll add it to the backlog. But if I ask a question now, can this appliance be used outdoors? So now it's carrying out a document search. Whoa, it looks like we're caught in a loop here. Yeah, I'll just stop that. Let me try a different model. So let's try the Quinn 3 32 billion model. And let's just try that question again. So new chat. Interesting, this model provides think tags, whereas the Mixture of Experts model didn't. So we can reproduce what we have on Claude actually for that. So you can see them there, the think tags. Can you render think tags similar to the screenshot where there's a thought process bubble essentially? Here's an example of how this currently renders on our application. Okay, that's done. Let's give it a shot. Oh, there's a thought process, so that's better. Brilliant. Styles could be updated a little bit, but that looks pretty good. Okay, it semi-broke here. Whoa, okay, stop. I think it's because there's multiple think tags here. This is a little bit buggy. So the first thought process bubble worked fine. Then it moved into the analyze document step. Then I got the tool response within that pop-up. That's fine. However, there's now another think tag of the agent. So we need a second thought process bubble. And also not all models use think tags. So you can't start it off just using a thought bubble. Yeah, so this is the edge cases that we need to test out for. There's quite a lot in this. They're quite sophisticated interfaces. Okay, so that's good. Then it's triggered the tool. It jumped again. At least now we have a second think tag, so we're making some progress. Whoa, massive bouncing all over the pages here. So there are still bugs here. It was pretty good up until this point. That should have been up there. We got into the summary of the document. That's pretty much what I asked for. But then for whatever reason, it duplicated it all. And then it stopped. Now, did all of this happen in LangSmith as well, or is that some sort of strange behavior that we are seeing in the front end or in the back end? Maybe it's an application bug. This seems to have worked correctly. So we have our input. It hit the analyze document with the ID, provide a summary. We get the tool call response. So this is the internal think of the sub-agent. This is what I'm talking about, how the sub-agent rendering is going to cause us issues. So the sub-agent is thinking, and then it sends it back up, and then our agent outputs this, and it thinks about it. There's a lot of thinking going on anyway. So, okay, let's start by looking at what the user provided is this one. So this is the thought process of this tool call, and this is the output. And I think this is specific to these smaller local models. I'll just switch it back to the OpenAI one. So it's GPT 5.2. And that's our base URL. So let's go into new chat. Yeah, the fact that that's rendering at the same time as the thinking would suggest that this is not actually the main agent thinking it. This is the sub-agent. Yeah, that's the issue. It looks like we're duplicating the rendering of the output from the sub-agent. It appears both as main agent text as well as sub-agent text in this box. So the sub-agent content should only ever render in that box. So not specific to local models, just a bug in our code, essentially. Okay, let's go again. That's much better. And really nice, actually, that you can see that it's still rendering and then the green tick. Brilliant. Can this be used outside? Now it triggers the document search. So that's the vector search. And it's obviously picked up this from the previous conversation history. Let me just verify that. Exactly, yeah. Can this be used outside? So it's still getting the full flow of the conversation. Okay, that's great. Now, final check. Let's put it back to the local model. We are nearly there, I think. So we'll copy that out. Let's Quinn 32 billion with thinking. This is our base URL. And let's get this back again. So now it's thinking. Yeah, just one small bug around the thought process here. So this one is the thought process that should be up there. We're nearly there. One small bug around the thinking tags. The think process showed up correctly, the bubble, and then the hide steps, and then the sub-agent. But then after the sub-agent finished rendering, the thought process bubble dropped back down underneath it, and then another thought process showed up. I need to figure out myself what's going on here. Let me just come back in again. We have our user message, trigger the analyze document. So actually, this doesn't seem to have had any thinking first. It then does some thinking. So this is like the first round of thinking, is it? This is the second round. So where is the thinking here? From looking at LangSmith, there's actually 3 traces. The first trace is my question and the thought process, and then the subsequent triggering of the analyze document tool. The second trace is then the sub-agent doing its thing, and that's fine. And then the third trace is almost like it has the full history, but it's missing the thinking tag in the trace itself. But the thinking tag is still rendered on the screen. So is that why the bubble is jumping down underneath the tool call response? So it is amazing how complex these interfaces can get. I think it has figured out the problem based off me providing the exact issue. So it is worth getting into the detail of it, I think. So we're restarting the front end. Okay, give it one more shot. Fingers crossed. So there's our thinking tag, and here's our tool call. So there's our second think tag. Excellent. This is perfect now. And there's our response. That's really good. And let's ask our follow-up question. Can this be used outside? Excellent. That's so good. Now let's swap it back in for our mixture of experts model. I just want to make sure that I can work with it because I was getting some really strange duplication of text streamed back. But I think it might have been actually sub-agent tool calls. So let's eject that. Let's load back up our 30 billion and we'll set our context length up to 70,000, which is probably as far as I can go on this GPU. And I'll need to change the settings actually. So this is the VL 30 billion. And now let's ask our question. Okay, so there's no think tags here, as you can see. We're getting the tool, the subagent response. There's a streamed answer. And then can this be used outside? So then it's carrying out a document search. Cool, there we go. Can this be used in the United States? So again, a bit of a document search. It's carrying out a few searches. It's now carrying out a web search and providing an answer. Excellent, we're properly up and running here. That's so good. Now let's step back again. So this is a very specific question. So let's go back to this question. Can you give me a summary of the Nair built-in oven? And here's the product code. So it's gone to document search. Then it triggers the subagent, which loads it all into memory and then answers it. Beautiful. Can this be used outside? Excellent. That is really good. So that's module 7 and module 8 pretty much built. Of course, more testing to be done, but end-to-end on all modules now. So let's just commit everything. So I'll clear this down. Okay, so it's pushed everything, created the tag, and now we are just releasing. And there we go, modules 7 and 8. So we have our additional tools, subagents, and dark mode. And that pretty much finishes this out. So from looking at the PRD, we have covered everything except deployment. And I'm tempted to leave this for a follow-on video on this series because there's a whole world in the deployment area that I want to cover. Not just a case of Dockerizing everything and deploying remotely, but I want to cover actually managing this as a production project. Because up until now, we have just been pushing without blinking to the main repository. But in reality, we need a dev environment, which pushes to a staging environment, which then releases in an orderly fashion to the production environment, carrying out database migrations and making sure everything is actually okay when we do that. We also need ways of rolling back if the push does not work correctly. So this is the real side of software development. Whether you're using AI coding or not, you need a way of formally managing the release cycle and release trains. So I plan on getting into that in another video. To be honest, where we have gotten this to, I would in all reality call this an alpha version. It hasn't been fully tested. I've done smoke tests end to end. There's been a level of validation that Claude has carried out, but there's a lot more testing to be done on this application. So I wouldn't be comfortable deploying it anyway. But let's go through it in another video in this series. But if you look at how far we've come, we now have an Agentic RAG system that has a full chat interface, that has a full documents system, that has a full ingestion system where you can drag and drop in documents. It uses DocLing. It can support the processing of PDFs, of DOCX, of PowerPoints. There is vision language model capabilities within DocLing, so you can tie in a VLM alongside your standard pipeline for processing these documents. Within the chat interface, we're handling tool calls, we're handling subagents. There's markdown rendering. Within our settings, you can swap in and out LLMs. There's embeddings configurations. There's re-rankers. Web search is supported. So it is amazing how far we've come in 8 short modules. And of course, all of this is a multi-user app. So different users having their logins. And then there's isolation through row-level security within Supabase. So the only unrestricted table is sales data. And actually, that is totally incorrect because unrestricted means anyone in the world can access. So we definitely need to enable RLS on this, but we are happy for that to be globally accessible to all logged in users. So we definitely need to set an RLS policy on that. And that's what I mean by this being an alpha version. There's still plenty of due diligence to carry out and make sure that this is actually ready for production. So on the one hand, we have come pretty far in these 8 modules. On the other hand, we are only scratching the surface. There's so much deeper that we can and need to go with this. As I mentioned, this is the first video in a series, so make sure to subscribe to see how this system evolves. But within our YouTube channel, we have over 30 videos that dive into the intricacies of some of these advanced RAG systems. I have an entire video on RAG design patterns. Here we talk about the benefits of pattern matching search as well as lexical and semantic. In this video, I show you how to use the deep eval system to actually evaluate AI systems on an ongoing basis. This video is about zero trust RAG. How do you secure your systems? I have a number of videos on knowledge graphs. This graph RAG video has over 135,000 views. Agentic sheets, re-ranking, multimodal vision RAG. So definitely subscribe to our channel and check out some of these videos if you're looking to level up your AI system. Now that you see what it takes to get a full RAG application up and running in Claude Code, check out this video here to learn all about context expansion, which is a great way to improve the accuracy of your RAG system. Thanks so much for watching, and I'll see you in the next one.